because both of my parents are graduates of University of Piraeus, and they're really honored. And I have heard so much about it over the years. So thank you.
I'm not going by alphabetical order by the way people are seated. So next we'll have Pavlos. Professor Pavlos Vlachos actually is wearing two hats, and we were very happy that he brings two perspectives here. One from Purdue and the other is from the pharmaceutical industry.
Good morning, everybody. So, first of all, many thanks. I'm grateful for getting to this point and after 2 years of work, actually getting to this milestone and this accomplishment. My remark here is going to be a little bit personal in the sense that I think it was a little more than 2 years ago when a delegation from faculty, Greek faculty from Purdue, we started on this journey where we wanted to build partnerships with Greece back home. And Elias, Dimitri, myself, a few other faculty were all part of the brain drain. And we've been going for 20, 30 years. So we really wanted an opportunity to just give something back and connect back home and acknowledge what actually got us to that point where we are in the United States, which is the quality of the Greek educational system, right? We are all products of that. We benefited from this education, and we are strong believers that we are producing some of the most amazing talent worldwide, and we really want to make the most out of it. So 2 years later, getting to this point where now we have this partnership, we can now bring these innovative programs to help male students across globally and transform towards this future that AI is creating for us. It's very exciting, but it's also very personally rewarding that we can actually now make that connection back home. So I really want to thank everybody for the hard work that we have put to get to this point and what will be the beginning of the start for many more programs and other partnership opportunities.
Juan Timoneta, professor actually at Purdue University from the policy side. So thank you.
Everyone, and thank you. Contrary to my colleagues, it's my first time in Athens, so in Greece in general, so it's a wonderful place. Again, thanks for the invite. I'm Juan Timoneta, assistant professor of political science and computational social science. My work now is on LLMs. That's to me the core of the AI revolution that we're living. But my focus is more on the technical aspects and the applied aspects of LLMs and political science, social sciences in general. I'm also developing models for low resource languages and government application. So that's a little bit of my research. And I've been involved with masters for a few years now. We're doing a lot of different documents, preparing modules for the courses. So it's a wonderful degree. And thanks again for the invitation.
I'd like to invite Litsa Panayotopoulos. She's honoring us with her presence. Litsa is actually, she has many titles and accolades. My favorite one is that she's a senior advisor to Purdue University here in Greece, and she's been an incredible driving force for many of our activities. So I'm hoping I'm not surprising Litsa for asking her to say a few words.
Good morning. It's more than a great pleasure and honor for me to just address all of you. And you can't really believe how happy I am, how honored that today, what we started discussing about 4 years ago is materializing. And especially with the University of Piraeus, which is one of the leading Greek universities, and Purdue is another of the leading public universities of US. I strongly believe, support, and advocated that the two countries, of course, US always will have connections, and always will have been studying, working, etc., all of us. We are honored as well most of the people at the Federal University are Greeks. So I'm looking very much forward to the first students that they are coming out with this dual master's degree. And then I have to say that we have to celebrate that very much indeed. So my strong wish is just to be extremely successful. We are here. Myself, just being in Athens, in connection with both the university and Purdue, anytime to do the best and see and having the greatest results, because our country has indeed so many great minds and benefits that we have to carry on and prove that many things we can do, as even the minister has done. So best of luck for everything and great success. Thank you very much.
Thank you so much, Rector Spaghetti, the whole University of Piraeus team. We are so thankful for the opportunity to partner. Thank you.
Thank you very much. This was nice introduction of Purdue and our partners. So I would like to call Professor Demosthenis Miliasis, the Vice Rector, who is also a part of the team that was every week there. Please, Dimo, just
Thank you very much. Just a few words, I think we're behind schedule, but I would also like to express a bit of my feelings for the realization of this program. As all the previous speakers have already discussed and pointed out, it has been a tough exercise. And certainly we are here today, but all these exercises were tough. On one hand, on the other hand, it was quite a learning process for all of us. So this program is a program that will address both universities. We look forward to it. It was a process that involved several different departments. It was challenging, and it was challenging because we had to face different administrative domains, different cultures, different academic calendars. At the end, different continents, with whatever that means. I'm very glad that there are many people from Purdue that are Greeks, but it's different, working and collaborating in Greece compared to US for sure. At the end, I think that the dedication, the flexibility, the commitment of the team led us here, and this is very important. On our side, I mean on the sub-department of the University of Piraeus, the research center that was responsible for managing the administrative aspects, that was also quite challenging. The minister is not here today, but I would say that, putting such rapid lines to draft, submit, all documentation at the time was something very challenging, and I would like to thank all the colleagues for that. Of course, we are not over, we are not finished, we are here to continue. There are many challenges ahead of us. Running the program, managing the admission, distributing the funds, all this stuff, which is also being quite challenging, but we are here to continue, we are keen to continue. And at the end, thinking back, I think that we have built a very strong foundation on which is the collaboration, right? This collaboration that is here, this is the foundation, and certainly according to our past and the success until now, we are sure that we will also do the same in the future. I think that this will be a successful program. We will have similar AI-related master programs in the University of Piraeus, Department of Informatics, and also Department of Digital Systems. But this combination and collaboration with universities brings value, and at the end will bring value not to the universities, but to the students and the people who will follow the program. Thank you very much, Purdue colleagues, for your commitment, for your flexibility. for our collaboration. I think that the program will be quite successful, and we will be glad that we were part of this process. Thank you very much.
I was going to present a little bit about the program, but I will have the chance to do it in another session because we are running out of time. So I would like to go back to Professor Spaghetti, and he will come here and declare the end of this session and the inauguration ceremony. But we will be talking about this program in other sessions as well. I have to say that it is very important because there is a collaboration between Europe and the States. It is a cross-Atlantic collaboration, and also it is in AI. It is a very innovative domain that is needed because there hasn't been any formal education on AI, but for many people. But now everybody is going to use it, and this is not going to be efficient for the whole society if universities who have the expertise do not educate people in the highest level of MSc courses and PhDs. So we are hoping that we will have this collaboration which will be very fruitful. We will expand it and have more sectors seen, and also that there will be some people that there will be industry people, there will be other sectors that will benefit from this master's degree. We have also a thesis in the master's degree of the Greek part, and we will be holding a conference every year among students. So this will bring us together more, and also we will have the opportunity to lead research with our students and also collaborations with industry. So this is our vision, and we really hope that it will be very fruitful. So I will ask Professor Tsakanax, please come here to say that we are having the end of this session, and we're going on to the next session. So Professor Tsakanax, Director of our University of Piraeus and the hosting general chair of this event, will close this session.
We close the inauguration of our joint dual master programs. I want to thank once again Professor Piraeus and all the colleagues from the Piraeus University. And we're very proud we came to the end. We hope to have a very which will start as soon as possible. Okay? Thank you very much. We're going to a 5 minutes break, 10 minutes at most, or to
We have the keynote speaker from Japan for 15 minutes.
Okay, we remain for 15 minutes in order to get. Okay. Remain.
Good morning, everyone. We are very deeply honored to have Professor Hironori Washizaki from Waseda University in Tokyo as a remote intervention keynote speaker. He's going to talk to us for about 15 minutes. He could not be here and attend the conference physically, but he has been to the University of Piraeus. He was at the university a couple of years ago, and he's a friend of the university and a collaborator with several faculty members of the university, including our rector. So if we can get started, Maria.
Yes, Professor Washizaki is online. Where can you see?
Okay. Now I unmute my microphone. Do you hear me? Okay. I hope I have you here. Okay. So, yes, I think good morning.
Hiro, can you, this is George. Let me introduce you first. Let me read a few lines regarding your professional experience and career so far. And then we'll be able to start hearing your presentation. So, Dr. Hironori Washizaki is a professor and the Associate Dean of the Research Promotion Division at Waseda University in Tokyo. He is also a visiting professor at the National Institute of Informatics of Japan. He works in industry as the director of system information and X-Motion to Japanese companies. He has received a PhD in information and computer science from Waseda University, and he serves as chair of the IEEE Computers Society Professional and Educational Activities Board Engineering Discipline Committee. He spearheaded the guide to the software engineering body of knowledge evolution. He serves as an associate editor of the IEEE Transactions on Emerging Topics in Computing. He is also a steering committee member of the IEEE Conference on Software Engineering Education and Training. And he's an advisory committee member of the IEEE Computer Science Flagship Conference, ComStack. He's a professional member of IEEE at Papua. He has served as the program chair of multiple IEEE conferences, and he's the program chair of the international programming education track of the ICPC. He's also a workshop chair, publicity chair of several other professional conferences. His research interests include systems and software engineering, he has published over 120 He has published over 120 research papers in international journals and conferences, and he has received several awards and honors, including the Best Paper Award and the Most Read Article Award from international conferences and journals. Since 2017, he has been the lead on a large-scale grant at MEX called MP Pro Smart SC, which encompasses professional education in Internet of Things, artificial intelligence, software engineering, and business. In the year 2025, he was the IEEE Computer Society President. Professor Washizaki, please take the floor.
Okay, yeah, for having me here. So, thank you, Chairman, and thank you all the organizers and also distinguished guests. So, thank you for having me. I'm Chairman Wasaki, and I'm the, as introduced that, I'm currently serving as the immediate past president of Microcom Society. And also, I'm working in Boston University as a full professor. So, today, I'd like to introduce you just briefly. Introduce you to particularly the sleep of that. That is one of the major products made by the society, and followed by some kind of research topics in AI and software engineering. Okay, so move on. Okay, so firstly, another major product made by the computer society is technology prediction. So every year, computer society envisions the future and what are the emerging and very promising technologies. And this picture is taken from the latest technology predictions. It was published this last January, and by the team led by our past president, Dehan. And those 26 breakthrough technologies have been classified into 6 layers, including energy, applied computing, non-functional characteristics, user interfaces, applied AI, and barcodes. And you can see that it's quite obvious to see that most of the technologies are about AI, such as applied AI, barcodes, and so on. Okay, so then, well, today, particularly, we're going to focus on software engineering. So, software engineering is about coding and beyond coding, right? Such as the software requirements, architecture, design, of course, coding as well, but also testing and management, and all those are about software engineering. And so, in this definitions, one of the major predict technology is future of coding. So, yeah, you can say that now in many practitioners are working on the coding with AI, and not just AI as a tool, but now in AI as a platform, right? Because particularly there are a lot of integrating agentic AI. And so yeah, indeed, future coding is having a kind of very significant impact on professional transformation, but also economic transformation as well. But at the same time, we have to consider some concerns, like such as quality concerns, ethics, security, and compliance issues, and so on. All those, kind of considerations are somehow documented in the technology predictions. So if you are interested, please download it. It is freely available. Okay. So then, in addition to the technology predictions, Computer Society also published the Sleep Guide, Software Body Knowledge. Okay? That is also one of the major products, and actually in these years, I think Copilot and OpenAI and so on. The key question is that how such agent coding and also their change proposals or change requests would be well adopted, well approved in the actual development environment. That's the question. So partly, it's a very famous study conducted by Ahmed Hassan's. They studied that how agentic pull requests, it means that change requests generated by agents will be approved or not. So they compare the approval rate of change requests, pull requests generated by AI and also made by human. Okay? Yeah, let's take a look at the left-hand side. So you see the kind of Mr. comparison between human versus OpenAI Codex. And blue line shows the human, and the orange line indicates the OpenAI Codex-based so agentic pull request. So you see that basically human is better. Okay, that's good. However, you see, for example, with respect to documentation, agents are better than human. So it implies that now software documentation is no longer human tasks, but agents can do much better than human. But also the question is why change requests by agents were not approved by human. That's the question. So our team carefully examined what was the primary cause of rejection. And the key finding is that, well, actually, we presented this 2 months ago at the MSR for physics, and fortunately, we got our opinion. So the primary cause of rejection was not technical failure. So that implies that human intervention and also human interview may have improved the approval of agent requests. In other words, change requests generated by agents. So that's the kind of ongoing study. So we have to study more about how agents and humans can collaborate in much healthy way. Okay? And after coding, of course, we need to do some more like testing and bug fixing and repair and also maintenance and also yes, and there are many researchers also working towards such direction. And this is just a kind of example of how also we are working in such automated software repair, but also bug fixing and also software maintenance. And so this demonstration shows that firstly, human experts document partially the detected bugs, but then any agents can support the enhancement of the refinement of the bug records and also prioritize them. And also try to locate where is the root cause, where is the actual bug. So and finally, but it is still a kind of ongoing research and researchers are working in such. So finally, really end-to-end program repair. Alright, so then finally, what are some other specific core gaps with the security? Okay, we are also working on the security and how security analysis could be empowered by large models, such as organizing threat knowledge, but also organizing security knowledge. And we are quite having good achievements in the organizing of attack patterns and also mitigate some identify threats and vulnerability and also protection. Yeah, but here's an example of what we presented last year. So this is a large model-based mitigation and also argumentation. How we can argue the of the safety information, right? So firstly, based on the given abstract input, okay, then a large model-based approach can generate identify some corresponding complete risks and also corresponding mitigation coordination. Alright, so then we have to assure those mitigations correctly correspond to the corresponding risks. Therefore, we are going to adopt an assurance case to argue that those mitigations are actually good solutions to address and mitigate corresponding risks. All right, so this is it. So as I showed you that, AI philosophy engine is exactly happening right now, and it is moving towards from AI system to AI partner to more, of course, agent to AI to have an AI human co-value creation. Because that's the kind of future we are moving towards. Okay, maybe that's it, and thank you for having me, and I hope you will also enjoy the rest of the conference. Thank you.
Thank you very much, Professor Washington, for this intervention. Perhaps in the future we can have the pleasure of having you physically here, but we still appreciate the presentation you just gave us. It was very inspiring and very important. But thank you very much. We are going to move to the first panel in this conference. The first panel will discuss scientific promises, challenges, and boundaries of artificial intelligence. And if I can have the presentation, please. In the meantime, the panelists, would you please, Professor Elias Milionis, Professor Joan Timoneda, Professor
Evangelos Sakopoulos, and Professor Evangelos Marinakis. Would you please come to the panel? They need a minute. Okay. While we are waiting, perhaps we should start with introductions to the panel members. Professor Bilionis, would you please present yourself?
Hi, Elias again, Professor of Mechanical Engineering. I work on agentic AI for science and engineering. I'm looking forward to telling you more about how you can use AI agents to accelerate scientific discoveries.
Okay, Professor Joan Timoneda.
Hi again, Joan Timoneda. I'm a professor of political science and computational social science, as I mentioned. My work is on LLMs in the social science sphere. I'm training models on, as I said before, on low resource languages, etc. So,
Professor Evangelos Sakopoulos.
Hi, very nice to be here. I'm Evangelos Sakopoulos, professor at the University of Piraeus, director of the lab for AI and the new AI node that we have got, thankfully this year, in the university, teaching software engineering with AI assistance.
And Professor Evangelos Marinakis.
Yes, hello. Congratulations also for the organization of the event today. I'm Evangelos Marinakis, associate professor at the School of Electrical and Computer Engineering of the National Technical University of Athens, with expertise on energy management, including also use of AI.
Well, thank you all very much. Let me introduce myself.
Maybe we need AI for better operation.
Let me introduce myself. My name is George A. Chikrintzis, or Syrintzis, as they would pronounce it in the United States. I'm a professor in the Department of Informatics at the University of Piraeus, and I was the head of the department from 2016 to 2020. I'm also a member of the administrators board, and I work closely with Rector Sfakianakis. My research works are in the area of artificial intelligence, and they have appeared in journals, conference proceedings, and books and book chapters. And I have founded or co-founded, and I'm co-editing 2 Springer series on topics relating to artificial intelligence. I was the editor-in-chief up until last month of the Intelligent Decision Technology journals, and I am currently serving as associate editor for 3 international journals. Let me try to introduce the theme of this panel discussion. And it may sound a bit unusual, but somebody, last year, somebody recommended this book to me. It is a book by a historian who was a professor at the University of Chicago. And the thesis of this book is that throughout human history, the strongest nations and the strongest states were the ones which possessed a technology that outperformed the technologies of their competitors. And as an example, back in the 11th century, the crossbow was such a technology. And of course, we all know and understand that in the 20th century, the states that possessed nuclear technology were the strongest ones. Why am I saying this? I'm saying this because it seems that today there's an arms race regarding building more powerful AI-empowered software systems. And the major players in this race are, of course, the United States, with extensive research on foundational AI. And this research is led by major companies such as OpenAI, Google, DeepMind, Anthropic, Meta AI, and others. Another important player is China, where applied AI research is conducted on foundational models, but also very many applications on facial recognition and robotics, and there are discussions about their national AI strategy. The European Union is a smaller player. They focus mainly on AI regulation, ethics, and trust, and this is mainly done through the EU AI Act. Other players are India. They are developing a growing startup ecosystem along with government initiatives, in particular for applications in healthcare and agriculture, and several Middle Eastern and African countries which are basically building AI infrastructure. This is not very convenient. I apologize about this. Let us take a look at what AI or has civilization and what it is currently doing. If we look back at history, we'll see that computer science, computer technology, and artificial intelligence have effected 3, not 1, but 3 different revolutions. In the last decades of the 20th century, we observed the digital revolution. Most of us, Dimitri, were students back then, and we lived through that. forecasting models to predict the weather in advance. And this is something that we could do only using computers. During the first 2 decades of this century, we observed the emergence of analytical, or if you wish, classifier artificial intelligence, which allows the processing of huge and diverse data sets and the extraction of information from them that cannot be done without use of artificial intelligence. What we have been observing during the last 5 years is the third revolution caused by artificial intelligence, and this is generative AI, which produces synthetic data sets. It does not simulate, but it does generate synthetic data. In summary, artificial intelligence, among other things, it makes use of extensive and models and data analytics methods. It accesses extensive databases and warehouses that are spread throughout the web, and it makes recommendations and supports decision making. And this is in reference to ever expanding application domains. Today, the most streamlined software systems are undergoing a transformation as they incorporate AI technologies in them. As a result, they operate with increased but trustworthy autonomy. They can analyze large data sets, which are not traditional, are not only traditional, but they may also include mobility data, activities data, buying habits, medical data, energy consumption data, and so on. And these software systems are continuously applied to ever broader application areas. Why do we need this empowerment of software with artificial intelligence? If we look at how much data was produced every day in the previous year, in 2025, the estimate is this huge number, 2 followed by 14 zeros in gigabytes. And this number is so big that if we were to store this data on CDs, for those who still remember CDs, the stack would surround the Earth 222 times, and at the current internet rates, it would take almost 2 billion years to download this data. And this is a huge amount of time, given that the Big Bang occurred less than 14 billion years ago. This gives rise to several questions. How do we select that part of the data that contain the desired information? How do we organize and manage this amount of data? How do we optimally or near optimally process it? How can we avoid misuse of data, especially sensitive ones? What networks and protocols need to be developed for effective? And also, what are new moral, ethical, and legal concerns that will align the processing of the data with human values? Knowledge of the experts in this field and intelligence, and this gives rise to interactions of humans with one or several AI agents. The software needs to be personalized or individualized. That means it needs to be oriented towards a specific individual or a specific group of individuals. The software needs to be dynamic in order to be able to handle complexities imposed by limited and biased data. The decision support needs to be transparent and ethical. That means it needs to be explained to the users of the software. The software needs to align with human values. And finally, we need new software engineering methodologies and new holistic software evaluation methodologies. Traditional software engineering and traditional software verification and evaluation are insufficient for AI-empowered software. At this stage, and probably not for quite some time, software will provide support, but it cannot replace humans. We need to keep humans in the loop. AI experts and AI engineers need to be part of the development of AI-empowered software as, and I'm quoting Eliezer Yudkowsky here, by far the greatest danger of AI is that people conclude too early that they understand it. And those of us who go to AI conference see sometimes people who are not really AI experts making the wrong use of AI tools and AI methodologies. And finally, holistic evaluation of AI-empowered software is required, and not just traditional verification and validation. And we are coming up with a book which is related to the Joint Masters Program, on which we are discussing some of these issues. Well, thank you very much, and let us move to the panel discussions. And, okay, if you give me just a second. I would like to pose 3 questions to every panel member, except Dr. Timoneda, because his expertise is slightly different from the expertise of the other 3 panel members, and very interesting expertise. I have slightly different questions for him. So if that is all right, maybe we can go that way. You agree? Okay. So for the 3 panelists, the first question is, what are the latest AI advances in your field? Maybe, yeah.
I can start. So my field is engineering, and in particular solving problems. And the latest advances is basically using AI agents. And when I'm talking about AI agents, I mean coding agents, Codex and Cloud Code in particular, and repurposing them to solve scientific problems. And by that I mean having them create models, write code that implements that model, calibrate the model using experimental data, and having a human review that the model is indeed correct and follows the data. This is doable right now. We do it. I lead a program funded by Eli Lilly on agentic drug discovery, where we do this sort of thing to discover new molecules and understand how they transfer through the body. If you inject them at different points in the body, will they go to specific organs? And the AI agents work in this field. They do accelerate scientific discovery, I would say 10 to 20 times. But the caveat is that you need a human to understand what on earth the results are and verify that they are correct. The way we pull it off is it's not just the coding agents themselves, so it's not sufficient to just use Codex. You have to give them 2 things. One is skills that encode domain knowledge, and we work closely with domain experts, biologists, chemists, all sorts of
you guys ask questions about. The frontier is making AI agents touch the physical world, having them interact with lab automation, lab instruments, so that they can run experiments autonomously. And we're actively working on that, and there are lots of things we can discuss about that, how to make it safe, how to make them sequential design experiments to achieve a specific goal, that sort of thing.
Great, thank you. Maybe for the panel, Professor latest AI advances in your area.
Yeah, right. So in software engineering and programming, that's actually just a text. And these LLMs have been used heavily in the last couple of years at least.
Now they are becoming more integrated with the standard way. There have been announced
a lot of things with them. Reality is that you need also to focus and see which tasks are actually being doing them, because the main challenge is what was the last comment, that at the end of the day you can produce millions of lines of code, even more than that, but somebody needs to understand what exactly it's doing, which is fine. It's just the same way that we treated the leap from going to punch cards and old compilers to IDEs and high-level programming languages. The code multiplies hundreds of times, the output one, and the software engineer needs to learn, and that's the competency that we try to teach, and perhaps that's also one of the main focuses of the program, is how to use also the AI to help you understand its own output. So yes, there are agents, there are tools that help you do mundane tasks, like for example, move code from dev to pre-production or production, check the full coverage of for testing purposes in order to see that everything is working as expected in a faster way. But also, the magic thing that came earlier with the AI in software engineering is that you can do quite complex tests now, which is a very interesting thing. So this actually means that you can have legacy software that is working out there, like, I don't know, your operating system that could be years old, running in a bank. And then you can go to that code and actually check and test more complex ways of actually see what it can or cannot do. And that's the biggest, let's say, advance that we have, that we can actually evaluate and have metrics and improve the software faster, much faster. And another thing is that we bring a little bit programmers closer to being guides than just mundane algorithms. Mathematicians that know how to tell a machine to do specific things. We will allow more people to go into programming with AI. We'll allow many more people from even neighboring disciplines. That has been done until now. So there have been analysts coming from mathematical background, physicists, but now we're that's the happy thing about what happened here with us, that we are allowing all the engineering disciplines to come into programming, and also other social sciences that for the first time in their years now, they can do automations in tasks with millions of that they had to ask a statistician to do it for them. Even though they understood how it worked, they couldn't actually do it themselves. It's like, having the automobile. Before the Second War, there was no gear. Now, people learn to do it with a gearbox, but automation, this makes it easier again.
Well, thank you. Professor Marinakis can play a dual role here because he's an associate professor at the National Technical University of Athens, but he's also presiding over one of the development companies of the city of Athens. So he can give us the perspective from one position and from the other position.
Exactly. In the energy sector, in general, AI can have a really important role. As we know, we have the grids, we have the integration of renewable energy sources, distributed energy systems. So better management and operation of grids is really important, and AI has really important role. Then we have other infrastructure like buildings, industry, where in general we have energy consumption, so exploitation of data and through AI models to be able to manage the operation of this infrastructure also is important. And in general, European Commission promotes this AI integration in the energy sector. Also next week we have a big event in Brussels in order to officially announce the AI foundation models for the energy sector. This is a new initiative where European Commission, together with the National Technical University of Athens and a cluster of energy-related organizations from grid, cities, buildings, will promote these AI foundation models for the energy sector. In the city of Athens and in general cities, we have a lot of infrastructure, so AI models can better support cities to manage this infrastructure. For instance, in Athens, we have the Athens Energy Portal, where based on data from energy consumption in public buildings, schools, and other infrastructure, we collect all this information. This then supports us to better monitor and also manage the consumption of the buildings, to know where we have to intervene and more. Or in the waste management, we have new installations of meters and sensors to bins or vehicles for waste collection. So this helps us to reschedule the program for vehicles to collect waste. So, and many other applications. The point here is that using all this data from different sources, smart meters, weather data, other energy systems, or even satellite data, we can create a lot of applications for cities, grids, buildings, and support daily operation for different levels of stakeholders.
Great, thank you.
George, if I may, I wouldn't want the social sciences to fall behind in the innovation discussion, because more than anything, I just wanted to, very, very brief note, that, in the social sciences now, we're developing almost the same that Elias was saying, and others, in terms of deploying agents, right? Like we are in the world in the revolution of deploying agents, and we're deploying them in a different way. We're not creating molecules, but we're creating other things, right? So we are all going to have to embrace creating agents in deploying in different aspects of our work. And one thing that I wanted to say that we're doing a lot in our field is building specialized fine-tuned models for very specific applications, right? And the social sciences are different on this because we have a lot of text. And we have a lot of very specific text, large amounts of text that we need to be better at, right? Models are great at a lot of things, but they're not great at everything. And building the specialized aspect of those models, building models that are better at very specific things, is one of the new frontiers, we think, and a lot of our work and my work is going in that direction. So I just wanted to add that a little bit as an area of innovation.
Great, Joanna. I was actually going to ask you, how are LLMs impacting student learning? And also, how is AI in general reshaping research itself, the way we do research?
Yeah, I mean that's a great question, and I think for teaching, I think there's two schools of thought. I've seen people be very against AI, very, denial of AI, telling people that shouldn't use AI in the classroom. We should stay away from it, and others that embrace it wholeheartedly, right? That embrace AI and move on with that, and it's not easy, right? Like because I think on the one hand we need to be able to evaluate competence. So if we embrace AI, how are we going to evaluate student competence, right? If students use AI, how are we going to know if they're actually learning anything or if they're just using AI? That's one of the challenges. And to me, one of the things I do, and we're doing now, or we're noticing this at the university level with, and I don't know if other colleagues have noticed similar processes, is creating the right incentives for students to use AI responsibly. Right, so making sure that exams or papers are not just simply done the way that we used to do them, but we have some guardrails to make sure that that they're in a controlled environment. So we're going backwards a little bit, right? We're doing comprehensive exams in a controlled environment, which is not ideal, but we have to do that. But in a sense, it's not to police, but it's to create the right incentives, right, for students to learn the right way, so that they get to a point where they can use that. But one point I wanted to make too with this is we need to decide what sort of skills are more higher level now, more, and what other skills are something that we can just do without the students learning, right? Like AI is going to allow students to learn things at a different level than they did before, right? And I always give this example that I gave Elias before of I don't know how to run a regression by hand anymore. I haven't run a regression by hand in ages because software does that for me, right? So, but 40 years ago, people were doing that all the time, and that was considered to be a key skill. That is something that we need to decide which skills are core and necessary skills that students need to learn, and which ones are skills that they can do without and still, do things at a high level with competence, etc.
Great, thank you. So now let us move to the second question. What are the main limits, challenges, and risks associated with AI in your field? Maybe Ilya?
Yeah, the main limit is the need for human validation. So the AI agents will produce results. You really have no way of trusting these results until someone looks at them and says, yeah, that's correct. That's a new finding. There's some ways, especially when it comes to engineering and science, to algorithmically test if something is correct. If you're producing a model and you have data, you can test if the model matches the data, what is the error, and you can look at the error and you can say this error is less than a threshold and I accept the result. Or if you have connected your agents to lab automation and you can have them do an experiment and make a measurement and see if the predictions are indeed correct, that would be another way to validate it. But it's not yet the same way as it would be with a human expert. If I show something to Pavlos, let's say, about fluid mechanics, he's going to say this is BS or this is correct right away. He's not shy of saying that. When something is BS, he's a BS detector. Sorry, I'm going to stop here. All right, so we don't have that yet with AI agents, okay? You need the humans to check their work. But that, it's a limitation, but at the same time, it's an opportunity for humans because it looks like for the time being, we're going to have a job to do. So, and it's very likely that because the testing a new hypothesis has become so cheap with AI agents, it's very likely that the demand for human validators is going to go up. So the demand for a high level of domain expertise, I think, is going to go up. We cannot predict exactly in which fields that is going to be, but my guess is that the core sciences will see increased demand for work.
Great.
It's a good problem to have.
Professor Sakopoulos?
Yeah, so I'll give another also
additional aspect. One of the main challenges of AI is energy. It's not going to be cheap. It's not going to be everywhere available. To treat this, you don't have to go directly, because Professor Marinakis can tell you more about the energy itself. But as a software engineer, we have been trying to teach people to be versatile and be easy to accept change. We call it in a nicer word, agile programming sometimes. But it's actually took us 40 years to understand that programmers should learn how to accept change and do what they do best, learn a new programming language every year, a new framework every year, deal with a new operating system in the phones, in the PCs, in the laptops every year. So all these changes that people are running need to be worked around for energy, which means that we need also to have a good understanding of how the different models work. So there's not a single model. There's not a single LLM, there's not a single model, there's not just one company. There are multiple solutions. Some of them have completely different demands in energy, like 20 or 30 times less or more if you like. They can be less accurate, meaning more approximate. I like to say that the AI revolution is the comeback of combinatorics and the part of mathematics that has to do with randomness to algebra, which is precision, and the scientists like to be very precise, while we tend to forget that we randomly take drugs that do 100 things wrong and just one correct, but we still take them because that one is good enough. So this is what AI is for software. It's going to do a lot of things very correctly, like 90%, 95%, 80%, and they will consume different amounts of energies, different amount of energy, different type of energy. So we need to be smart. There is a movement, for example, in some big conglomerates to move out from specific data centers with AI to local installations that will consume less energy with different models. So we need to learn also infrastructure. So that's a learning thing. Like doing things in the cloud, doing things in local computer. It's an infrastructure thing.
Exactly. The energy consumption of all these AI models, especially in the energy sector, I think it's a big challenge because we have this paradox to say that we are trying to reduce energy to promote sustainability goals, but at the same time use energy-intensive technologies to support this process. So, of course, this is really important. Other challenges also is first of all, the availability of data for some domains in the energy sector. For instance, in Athens, before I say, we have this Athens Energy Portal for the buildings, but 3 years ago, we had for the buildings only some Excel files with some buildings, some data. Each department has different files. It was a mess. So we started a process with the installation of meters, sensors, then to collect data, to receive data for a long period, and on top of this data, to develop the models to support different processes for the optimization of buildings. Other challenge also is data sharing, especially in the energy sector. We have different stakeholders, and many times it's difficult to secure the ability and transfer of data from one stakeholder to other. So also process to support this data sharing concept. And in European Commission, we are trying through data spaces and in general technologies with AI to address this challenge. And of course, explainability, all these things that, okay, I think it's similar with other sectors, but also in the energy domain, we need the involvement of end users, the human interaction,
And of course, always we need to have in our mind that AI also in the energy sector, the role is to support decision making, of course not to replace human responsibility.
Great, thank you, Vangeli. And I'm going to modify the question for Joan. Are there any political biases in AI? And if so, where do they come from? And what is the impact? What do they mean for society? And also, I'm asking him long questions. Who decides what the neutral answer is?
Yeah.
What it should look like?
Yeah, so my answer to the previous question would have been the same, right? I think for us the biggest challenge is bias and bias in these models, and I think it's the elephant in the room for a lot of these companies now and how to deal with biases. It's been like that for a few years, but biases are inherent in these models, and it's difficult to accept some of the things that the models can do. And so companies need to be very, very aware of that, and they are taking measures. But I think of the biases in these models as a bit of a pyramid. So there's the data at the very bottom. Data is biased by definition because it comes from, first it comes from the internet, it comes from all of us, and we all have different points of view. We all have, sadly, there's some racist in the world, there's some sexist in the world, and that ends up being in the data, right? And there's people that are not like that, and that's also in the data, right? But the model picks up these patterns as it learns, right? And these patterns eventually are part of the weights, and then they eventually become part of the outcome, of the output of these models, right? So the data itself is a source of bias, and it's a source that is very difficult to change, right? Because that's how the models learn. So the models inherently learn biased patterns, and that's almost, it's impossible to really fix. And that's something that we need to grapple with at a deeper level. But besides the data, then there's this second level of the algorithm itself, right? The algorithm, nowadays models are becoming bigger and bigger, and you're starting to slice them into a mixture of experts, and different experts that activate different parts of the network. And you have routers that are based, they're effectively just from the training data, so there's not a whole lot of post-processing in the way that these are routed. So if, for instance, one expert deals with a minority category, but then a bunch of other experts deal with a bigger category or a social group, you might have algorithmic problems even at the way that these models are functioning. This is a bit more speculative, but I've been thinking a lot about this recently, and I'm happy to if anyone can chime in on this. But the one that everyone probably understands at a more moral level is the top of the pyramid, right? How companies decide what is right and what is wrong in the output. Companies, because we know the data is biased, they need to do reinforcement learning with human feedback so that the models don't go crazy, right? GPT-3 would say really racist things, right? GPT-3 would say very sexist things. So companies like OpenAI and Anthropic and others have to grapple with how do we make the models align with human values, and that is a really difficult thing to do. The companies decide through reinforcement learning. The model is asked to give like multiple answers, and then a human says which one is right and which one is wrong. And so who decides which one is wrong, right? If you see a racist answer, if you're a racist, you're going to think that that's the right one. If you're not a racist, then you're not, right? So companies, eventually, there's a human element and a human moral element behind the decision to say, well, this is the right way to answer a question by the model. But then that means that the companies are deciding what's the moral compass of society in some ways, right? Because these models are giving answers that align with some company values. And that probably shouldn't be the case, right? I think this is much of a bigger societal discussion that we need to think about all together as to what the type of answers we'll be happy with the model giving. Just one little aside, one paper that we've been working on now, I've been testing different models on how they align with views on abortion, for instance, right? And you see, for instance, Claude is extremely neutral. No matter if it knows that you're conservative or liberal, it's always producing neutral answers. Grok, which, right, we can all understand how that's going to go, aligns with the user perfectly, right? If you're anti-abortion, it gives you conservative answers. If you're pro-abortion, it gives you liberal answers. And there's no real post-processing. OpenAI is a bit different. It does cuts at the extremes, so the extremes become neutral, but then the middle part OpenAI usually allows more pro-abortion liberal answers to moderate users, right? And this is an ongoing project, but what it really hammers home is how these companies are addressing bias, right? And they're addressing it in very different ways, and we're allowing them to, and there's no real supervision or regulation around that. So that, I think, because bias is so inherent in all parts of building an LLM and deploying an LLM, that is really going to become one of the bigger, it is a bigger challenge now, and it's going to become one of the bigger discussions in the future, I think.
Great, thank you, Joan. Let's go to the final question for all panelists. Well, I'll modify it for Joan again. What AI-related skills and educational backgrounds would you look for when hiring people to work with you, and now and in the future?
I can start. I'm hiring right now, okay? So talk to me. The skills I require is basically deep domain expertise on a specific field, okay? So I'm hiring engineers. So I want people to be good engineers, right? So right now we need mechanical engineers, chemical engineers, biomedical engineers. I don't think you can succeed in my field without having deep domain expertise. That said, there are some skills that you need to know on top of that. In my case, is how to use correctly the AI tools and knowing what are their limitations. In my particular case right now, these would be coding agents, like knowing how Codex and Cloud Code work, harness design, what is a harness, and how can you use it to give an AI agent long-term memory and goals and a to-do list and so on, and how skills work, what exactly they are, and how you can make skills with a harness. I know this all may sound, I don't know, very weird, but that's what I'm looking for. Now, I would accept somebody that doesn't know any of that stuff if they have the domain expertise and they're willing to learn fast. But I don't see doing engineering, especially on the computational side, without these tools in the foreseeable future. The way we were doing engineering in the past is dead. We have seen tremendous acceleration in research output using these tools. There's no way around it.
Γιώργο, καλημέρα.
Professor, we are in the middle of a panel. Can I call you in a few minutes? He's our keynote speaker for later this afternoon, and he's calling from the US, so I had to answer. Apologies for this. Okay. Professor Sakopoulos.
I completely agree that the domain knowledge
helps. It's essentially. But other than that, for the new people that start now their career, in software, we learn during school time that being agile is important. Knowing best practices is important. Now we have to look for, and we are looking for, in all of the spectrum of software engineers, junior, mid, senior, the capability to work with the AI coders. This means that, practically speaking, you need to be able to have skills on how to control them, how to guide them, and in order to do that, you need to have, for example, AI security for the code awareness. So how to write code like correctly in order to be secure. And secure is, in this case, like a safety thing, like inventing the seatbelt for the code. So we want less bugs in the code by design and by default. Out of the production, we used to treat bugs because of the agility. We said, okay, every Tuesday we will have an update in our phone. In your phones, you get updates of the apps every now and then, quite fast. With the AI, security awareness is more important because that's a tool that also malicious or adversaries can use. So when you put in production something that has a bug and you haven't tested it correctly, and you haven't learned how to test it correctly, that can be an open door to a lot of not nice things in your software. So we want people to understand that we don't just put out code there and it's fine, it's working approximately, because it can really bring a lot of troubles. Just to give you some headlines, last week GitHub itself lost all crypto secrets, and GitHub people are not just any other people. I mean, they have been treating their code, which means that in thousands of software developers, we need all of them to be able to do development correctly, having security awareness correctly, and also knowing how things work, which is called, it used to be called operations, systems management, that we have a little bit forgotten because everything has got automated and gone to the cloud and it's a black box for everyone. No, it's not a black box. Your code is running there. You need to know how it actually works, because the big job of the future is what Elias said, that we need to evaluate the result of the AI. That's the big job. We need to be able to do that, and to do that, we need to learn the basics. We need to learn the fundamentals of our domain. If we don't, it's not going to be, the AI is not going to be enough. If you want to be a Formula One driver, the driving license is not enough. You need to understand the car, you need to understand how the physics around the car work. So if you want to be top in your game, you need to also know that. That's what we try to direct people to.
The same also for me, especially in the energy sector, to combine technical background with data science, machine learning and more, with domain knowledge in energy, climate science and other fields. I think this is the ideal combination. This is also what we need. Of course, from our side, we are very close. We are within the source of engineers at the university. Mm-hmm. So it's easy to find persons. The challenge is to keep them, not move to US many times. Because I think we have also in Greece very strong expertise, experts, I mean, very good students who can support many activities. And also in general, this combination of AI knowledge with energy knowledge, this is what we will try to do in the course of the program AI for Energy Management and Smart Cities. So we have also a structure to combine different fields in order to help also participants to understand also technical and domain knowledge.
Great, thank you. And now the modified question for Joan. LLMs are evolving very rapidly. What would you like to see as the next step in their development?
There we go. So, I mean, I think a lot of this we've already touched, right? Like, I think there's the current frontier, everything moves so fast, right? That the current frontier now was the next frontier last year. And so agentic AI, we're all, talking about agentic AI, we all do agentic AI, but a lot of I would just say the population at large doesn't necessarily, is not as aware of it because it's a really recent thing. Like Claude Code was deployed just a year ago, and it's been growing a lot. So I think agentic AI is not the next one, it's the current one, but it feels like the next one because it's so recent, right? So just people should be aware of agentic AI, how companies are going to start using agents that talk to each other, that produce tasks, that can run independently, and that leads to potential job displacement problems, and that's something else that we can discuss if there's time. But I think the frontier going forward is going to be specialized LLMs, specialized AI, domain knowledge, right? Like that's where, because we're focusing all development efforts into these big models that again, as I said before, are great at most things, but they're not excellent at everything, right? And there's going to be, the market is going to push for certain development of certain LLMs that are, or certain AI tools that are going to help in very specific domains. That's how we're going to eke out a little bit more productivity in the long term, right? By creating specialized domain-specific AI models.
Thank you, Joanne. We are only 3 minutes late, which is miraculous for Greece. I don't know if we can take an additional 2 or 3 minutes to take questions from the audience, or are you too hungry to do that? Lunch will be served right after this panel, but if there are maybe 1 or 2 questions, we can. No? Okay, let us thank Professors Bilioni, Sakopoulos, Marinakis, and Timoneda for the very insightful discussions we just had. We hope the audience enjoyed the panel, and we hope that some of the ideas that were presented will be in the mind of those who will further develop these AI tools. Well, thank you very much. We are going to break for lunch, and we'll come back. We'll have a keynote address by His Excellency, the Minister of Digital Governance of Greece, and a second keynote by Professor Nick Bourbakis, he just called, who is one of the leading experts in artificial intelligence worldwide. Thank you very much, and we'll come back in about an hour from now.
Ιστορικό. Είναι εκεί πάνω. Τι πες? Είναι πάνω γιατί θα έχουμε κουστάρει.
Κοίτα εδώ. Καλησπέρα σας. Σας παρουσιάζουμε την Άννα Λιανέρη. Την 5 φορές πρωταθλήτρια σκάκι.
Εδώ πέρα παίρνεις, έχεις ένα περίεργο... Σου αξίζει θα έχεις νωρίτερα, θα το έχουμε σε γκρουπάκι του πάνω. Τρία, 4, 5, 6, 7, 8. Δεν θα σχολιάσουμε, βλέπεις, είμαστε κύριοι. Είμαστε καλά παιδιά και τα λοιπά. 1, 2, 4. Για 4, 5, 6, 7. Δώσε ρε παραπάνω. Όχι, να το κάνουμε τώρα από το τέτοιο ρε. Όπως το έκανα πριν, δεν το είδες. Μαθηματικά. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, check. 1, 2, 3, 4, check. 1, 2, 3, 4, check.
Ένα. Ένα. Γιατί είναι τόσο χαμηλά. Ένα. Ένα. Hey. Ένα, δύο, τρία, τέσσερα. Δείξε. Όχι.
I hope you enjoyed the lunch. We can continue with the conference schedule. We are very honored to have His Excellency, Mr. Dimitrios Papasteriou, Minister of Digital Governance and Artificial Intelligence of the Hellenic Republic, as a keynote speaker. Unfortunately, he could not attend physically due to commitments. We all understand that ministers, members of the government are busy people. And instead of that, he has sent us a taped video with his presentation. Before we start the video, let me say a few things about the minister. He holds a 5-year diploma in electrical and computer engineering from the National Technical University of Athens. Since June 2023, he has been serving as Minister of Digital Governance of the Hellenic Republic. Previously, he served as mayor of the city of Trikala for 2 consecutive terms, spanning the period 2014 to 2023. He has also been elected as president of the Central Union of Municipalities of Greece for the term 2019 to 2023. During his tenure as mayor of Trikala, the municipality was recognized as a strong model municipality due to pioneering and innovative work in digital technologies. Mr. Papadimitriou has been involved in studies and constructions of private electromechanical projects and the development of hardware and software programs. In 2007, he entered the field of renewable energy sources, and he has participated in the construction of over 300 private renewable energy sources projects. For his leadership, Mr. Papadimitriou has received various national awards, which include the award of the Department of Informatics of the University of Piraeus and the award for Manager of the Year 2025. Let us start the video, please.
Αυτές οι στιγμές που θα ήθελες να είναι διαφορετικά, αλλά δυστυχώς δεν μπορώ να είμαι κοντά σας. Ενώ το είχαμε κανονίσει με το Πανεπιστήμιο Πειραιά, με την φίλη μου τη Μαρία, να είμαι εκεί κοντά σας. Δυστυχώς είμαι ακριβώς απέναντι. Είμαι στη Βουλή των Ελλήνων, όπου σήμερα Πέμπτη έπρεπε τελικά να παρευρεθώ στην Ολομέλεια για την ψήφιση ενός νομοσχεδίου που έχει πάρα πολύ ενδιαφέρον βέβαια και με τα θέματα τα οποία συζητάμε. Ένα νομοσχέδιο για την κεντρικοποιημένη ανταλλαγή πιστοποιητικών ανάμεσα στα κράτη-μέλη της Ευρώπης. Το συνέδριο έχει πάρα πολύ ενδιαφέρον για κάτι το οποίο είναι εδώ, δεν έρχεται. Η τεχνητή νοημοσύνη υπήρχε πάντα γύρω μας, αλλά η αλήθεια είναι πως απέκτησε ορατότητα τα τελευταία 3-4 χρόνια για το ευρύ κοινό, κυρίως χάρη στα μεγάλα γλωσσικά μοντέλα. Και το θέμα τώρα είναι να δούμε πού βρίσκονται τα κράτη-μέλη, τι γίνεται με τις υποδομές μας, τι γίνεται με την κυριαρχία συστημάτων και δεδομένων. Αλήθεια, αυτό επηρεάζει την δημοκρατία μας, μήπως πρέπει να πάρουμε μέτρα. Τι γίνεται με την προστασία των ανηλίκων στο επιγραμμικό, στο online περιβάλλον. Αυτά είναι μόνο κάποια από τα θέματα τα οποία σήμερα εδώ στο Υπουργείο Ψηφιακής Διακυβέρνησης έχουμε να αντιμετωπίσουμε. Και ας πάρουμε τα πράγματα με τη σειρά. Λένε πως η τεχνητή νοημοσύνη θέλει 3 πράγματα. Θέλει ταλέντο και στην Ελλάδα υπάρχει τέτοιο. Η Ελλάδα έχει πολλούς μηχανικούς, έχει μαθηματική, αλγοριθμική σκέψη. Νομίζω πως γι' αυτό φημίζεται, αποδεικνύεται και σε πολλές μελέτες. Θέλει υποδομές και θέλει και δεδομένα. Πάμε λίγο στις υποδομές, όπου σήμερα στην Ελλάδα γίνονται πολλά και σημαντικά πράγματα. Την ώρα αυτή, μερικά χιλιόμετρα μακριά από εδώ πέρα, από την πλατεία Συντάγματος, στο Λαύριο, κατασκευάζεται ο πρώτος εθνικός υπερυπολογιστής στο πλαίσιο της πρωτοβουλίας για τα AI Factories, μια ευρωπαϊκή πρωτοβουλία για απόκτηση τέτοιων υποδομών, αλλά και την δημιουργία οικοσυστημάτων, γιατί δεν είναι μόνο ο υπερυπολογιστής, αλλά έχει και ένα δεύτερο μηχάνημα στην Κοζάνη, όπου και εκεί δημιουργούμε εθνικές υποδομές για inference χρήση. Έλεγα νωρίτερα πως το οικοσύστημα είναι αυτό το οποίο μετράει, γιατί το εργοστάσιο τεχνητής νοημοσύνης δεν είναι μόνο ένα HPC, ένας μεγάλος υπολογιστής, αλλά είναι και μια ομάδα πλέον ανθρώπων, ένα κέλυφος, το οποίο έρχεται να φέρει κοντά του πανεπιστήμια, ερευνητικά κέντρα και νεοφυείς επιχειρήσεις, προκειμένου να δώσει τη δυνατότητα σε αυτούς τους τομείς και σε αυτούς τους ανθρώπους να έρθουν πιο κοντά και να χρησιμοποιήσουν μάλιστα και δωρεάν υποδομές optimized για τεχνητή νοημοσύνη. Λέγουμε επίσης ότι θέλουμε και δεδομένα. Και την ώρα αυτή στην Ελλάδα έχουμε να παρουσιάσουμε πραγματικά κάτι εντυπωσιακό. Η χώρα έχει μείνει πίσω τα προηγούμενα χρόνια στην ανοιχτότητα των δεδομένων. Πλέον στο data.gov.gr, εκεί που είχαμε μόλις 84 μέχρι πριν από 10 μέρες ανοιχτά datasets, πλέον έχουμε 22.000 ανοιχτά datasets έτοιμα να τα προσεγγίσει και να τα χρησιμοποιήσει όποιος θέλει να κάνει έρευνα, να βγάλει προϊόντα, να χρησιμοποιήσει τέτοια δεδομένα για στατιστική χρήση και μάλιστα καλής ποιότητας δεδομένα τα οποία διαλειτουργούν. Πολλά από αυτά είναι online, με APIs, με JSON εντολές και προφανώς και κάθε άλλη μορφή αρχείου CSV κλπ. Αυτά λοιπόν σε σχέση με τα πολύ βασικά της τεχνητής νοημοσύνης. Όμως θέλουμε και συνεργασία. Βλέπουμε πως τα πράγματα αλλάζουν ραγδαία γύρω μας. Κάθε χώρα θέλει να έχει τη δικιά της δυναμική στην τεχνητή νοημοσύνη. Η Ευρώπη πρέπει να κτίσει και τη δική της κυριαρχία. Απέχουμε αρκετά από το να έχουμε δυστυχώς την αυτάρκειά μας και ούτως ή άλλως αυτό ήταν κάτι μάλλον οξυμόρο την ώρα που δεν έχεις σε υποδομές και chipsets την αυτάρκειά σου. Όμως εδώ πρέπει να παλέψουμε περισσότερο και όλοι μαζί για να δημιουργήσουμε αυτές τις υποδομές και να χρησιμοποιήσουμε και πλατφόρμες ή cloud services ή μοντέλα τεχνητής νοημοσύνης τα οποία έχουν την έδρα τους λίγο πιο κοντά μας για παν ενδεχόμενο. Και τα πανεπιστήμια είναι αυτά τα οποία μετατρέπουν τη γνώση σε προϊόν, την εξελίσσουν και χρειαζόμαστε τη γνώμη τους και τη στήριξή τους. Η δουλειά που γίνεται στο Πανεπιστήμιο Πειραιά είναι πραγματικά εμβληματική και άξια λόγου. Έλεγα νωρίτερα και για κάτι άλλο το οποίο πρέπει να μας απασχολήσει και έχει να κάνει με την ποιότητα της δημοκρατίας, την εποχή της τεχνητής νοημοσύνης, την εποχή των bots. Είναι κάτι το οποίο οφείλουμε να δούμε εμείς ως Ελλάδα, ως Ευρώπη. Λίγα μέτρα μακριά από εδώ, από το Σύνταγμα, κάτω από την Ακρόπολη, γεννήθηκε η δημοκρατία. Σε μια δημοκρατία στην οποία χωράνε όλες οι φωνές, αρκεί να σηκώνεις το χέρι σου και επώνυμα να λες την άποψή σου. Σε μια τέτοια εποχή λοιπόν που η ανωνυμία στα social media, η ανωνυμία αλλά και η τοξικότητα που δημιουργείται από διάφορα bots στα social media θέτει σε κίνδυνο τις βάσεις της δημοκρατίας και αυτό είναι κάτι το οποίο επίσης καλό είναι να βάλουμε στο πλαίσιο του δημόσιου διαλόγου και μέσα από τα πανεπιστήμια που νομίζω πως είναι η πηγή που γεννώνται τέτοια ερωτήματα και τέτοιοι προβληματισμοί προκειμένου να μπορέσουμε πραγματικά την επόμενη μέρα την τεχνολογία όπως αυτή μετατρέπεται ή μεταφράζεται στα social media ή γενικώς στον παγκόσμιο ιστό, να την φέρουμε πιο κοντά μας και να τη χρησιμοποιήσουμε ως ένα θετικό εργαλείο δίπλα στον άνθρωπο. Και λέμε για τον άνθρωπο γιατί θα πρέπει να συζητάμε πάντα για μια τεχνολογία και μια τεχνητή νοημοσύνη η οποία δεν θα είναι μπροστά από τον άνθρωπο. Η τεχνολογία πάντα θέλει να εντυπωσιάζει, είναι εγωίστρια. Θέλει να δείχνει ότι αυτή τα κάνει όλα καλύτερα, τα κάνει πιο γρήγορα, τα κάνει πιο αποτελεσματικά από τον άνθρωπο. Συνεπώς, θέλουμε μια τεχνητή νοημοσύνη η οποία θα είναι δίπλα και θα υπηρετεί τον άνθρωπο και αυτό το όριο, αυτά τα πλαίσια πρέπει εμείς να τα βάλουμε σε μια εποχή που βλέπουμε πως οι κίνδυνοι πολλαπλασιάζονται. Πολλαπλασιάζονται για τη θέση του ανθρώπου, για την εργασία του ανθρώπου, αλλά και για την ασφάλεια των συστημάτων. Για παράδειγμα, η ανακοινώση της ανθρώπικη για το νέο της μοντέλο στο μύθος, αλλά και η ανάγκη να τρέξουμε γρήγορα και να καλύψουμε κενά που πιθανώς να υπάρχουν, μας βάζει σε πάλι μια θέση άμυνας και σε μια θέση που πρέπει να δράσουμε όλοι μαζί περισσότερο. Συνεπώς, θα έλεγα πως υπάρχουν δύο κομμάτια τα οποία πρέπει να δούμε. Το ένα κομμάτι είναι το τεχνολογικό, το πώς κτίζουμε συστήματα, το πώς δημιουργούμε γλωσσικά μοντέλα και μάλιστα ανοιχτά γλωσσικά μοντέλα σε όλες τις γλώσσες. Όλες οι γλώσσες πρέπει να μείνουν. Οι γλώσσες μας είναι κομμάτι της ταυτότητάς μας, είναι πολιτισμός και συνεπώς πρέπει να τις διατηρήσουμε. Και το άλλο κομμάτι είναι το ανθρωπιστικό και τελικά πώς βλέπουμε τον άνθρωπο μέσα σε όλο αυτό το νέο παγκόσμιο τεχνολογικό σκηνικό, το οποίο αλλάζει και το οποίο κακά τα ψέματα την ώρα αυτή κυριαρχείται από μερικές και μόνο εταιρείες. Θέλει προσπάθεια, θέλει κοινή δράση και πάνω απ' όλα θα πρέπει να συνεχίζουμε να θυμόμαστε ότι είμαστε άνθρωποι και θα πρέπει να συνεχίζουμε να σκεφτόμαστε και να φερόμαστε ως τέτοιοι, έχοντας την τεχνολογία μόνο δίπλα μας και μόνο ως ένα εργαλείο για να κάνει τη ζωή μας καλύτερη και τον κόσμο μας ομορφότερο. Ευχαριστώ πάρα πολύ για την πρόσκληση. Καλή επιτυχία στο συνέδριο και ελπίζω την επόμενη φορά να μην έχω νομοσχέδιο στη Βουλή και να είμαι εκεί μαζί σας.
I guess the reaction of some people, it's all Greek to me. It was real Greek, actually. But the protocol actually obliges members of the government to address international fora in Greek when they are in Greece. Otherwise, he would have addressed the audience in English. And well, he's a very eloquent speaker, the minister, and I think this showed, even though he was speaking Greek, but I guess you could see the subtitles which were in English. We can now move on to our next keynote speaker, who is actually, right now, he's actually in the United States. He's of Greek descent, but right now he's based in the United States. The next keynote speaker is Professor Nikolaos Bourbakis, and he will join us live from his home in Ohio. Are we ready to, okay. Maybe we can start the link. Nick, can you hear us? Nick, we can hear you. Can you hear us?
Can you hear me? Hello?
We can hear
Hello?
you. You don't hear us. Can we send him a message or something?
Yes. Yes, I can hear you from another device.
Okay.
Yes, I can hear you, but can you hear me? Can you hear me?
Yes, we can hear
Okay.
you, Nick.
I'm ready.
Okay, let me introduce you then, and you can start the presentation of your keynote. So,
Yes.
Dr. Bourbakis is currently an honorary professor at the Technical University of Crete in Greece and a visiting
I
professor.
have another device.
And a visiting professor at Purdue University in the United States. Okay. His most recent previous appointment was as a distinguished professor of information and technology and director of the Center for Assistive Research Technologies at Wright State University in Ohio. He's the founder and chief editor of the International Journal on Artificial Intelligence Tools, the International Journals on Monitoring and Surveillance Technology Research, and the Transactions on Bioengineering and Bioinformatics. He has also founded, and he's the steering committee chair of several international IEEE Computer Society conferences, including the International Conference on Tools with Artificial Intelligence, the International Conference on Bioinformatics and Bioengineering, and the International Conference on Information Intelligence Systems and Applications. He pursues research in assistive technologies, applied artificial intelligence, bioengineering, information security, and parallel and distributed computing. His research is funded by USA and European governments and industry. He has published extensively in IEEE and other international journals, and he has graduated as the main advisor several dozens of doctoral students. His work has been internationally recognized, as he has received several prestigious awards. These include the IEEE Computer Society Technical Research Achievement Award, membership of the New York Academy of Sciences, ASC Outstanding Scientists and Engineers Research Award, IEEE Biomedical Engineering Award, and so on and so on. He is an honorary professor at the Technical University of Crete, and he has also received an honorary doctorate degree from our University of Piraeus. Professor Bourbakis, please take the floor. I don't think he heard me.
Πότε μπορώ να ξεκινήσω?
Nick, can you hear us? We are ready. Go ahead.
Okay. Okay, thank you. I would like to thank you all for inviting me to present in this conference my views and some opportunities and challenges related to AI. And especially I would like to thank University of Piraeus and Purdue University for the invitation. More specifically, special thanks to Professor Michael Sfakianakis, Rector of University of Piraeus, Professor Maria Virbu, Dean of the School of Informatics and Communication Technologies, and Professor Tsifridis, member of the Governing Board of University of Piraeus, and thanks to the authors and others that I'm going to use some of their material for this presentation. The outline for this particular presentation is a quick introduction to AI on the way that I have seen it the last 40 years, more than 40 years. Opportunities and challenges, starting with opportunities with is AI the road for a great future? And challenges, are we ready for new issues? And we go then, after that, machines, humans and machines evolution and the conclusion. And by starting with that, we go with artificial intelligence. A definition given to 1991 by myself was, and modified very little. Artificial intelligence is the science, is the study, the evolution and behavior of intelligent machines. When intelligent machines they have behavior similar to the humans, but not the same, and they are using incremental capabilities of learning, sensing, searching, creating rules and patterns, and planning, solving difficult problems, understanding, interpreting events, and so on. But because of the AI, we have to think in a different way, because the evolution of computers and AI has given us many opportunities. Now we have a pyramidal structure here. We collect data in astronomical numbers, and we have storage problems. We produce, from data, we produce information which has reached large numbers and difficulties to evaluate. From the information, we create knowledge, which is an impressive level, but we so far is doing okay to some degree from storage point of view, and to some degree used. And from there, the generation of intelligence is coming in big numbers, but it is controllable so far. The most difficult part and worry part is the achievement of wisdom. And it is at an incredible low level, and this is a major worry. But Moving there, we go to the classical view of AI. That was long ago that I have studied this as AI as an entity that has perception, knowledge perception as an input, knowledge representation as a memory, processes. One of them is learning, the major probably one, and action as the output. And in the center of this, it was logic, and it is logic. And I mean logic because without logic, there is no AI or many other things. And logic came as Aristotle, a Greek philosopher, mathematician, engineer, 384 to 320 BC, has introduced monotonic and non-monotonic logic, which represent the foundation of AI. And we move now to a modern machine learning scheme that was developed many years ago, which starts from local global graphs for structural representation of information, stochastic Petri nets for functional representation of information, and neural networks and deep learning for learning and decision making and feedback on this process. And as you can see, this is one is the mapping and the other is an isomorphism. With that model, we have produced great results so far with my colleagues and my students. And a quick AI categorization in time is given here. We have started with application-specific AI, solving and learning from a specific problem in an incremental level. We move to generative AI, which is a subfield of AI that use models for producing text, images, videos, and others, and combine them. A general purpose AI, which is actually a combination, a collaborative set of application-specific AI modules with the capabilities to solve more complex problems and learn through them and improve the interactions. We move to hybrid AI, which is in a scientific field that deals with the issues and activities in the intersection of biological and artificial intelligence domains. And now we are somehow in the area of advanced AI, where the intelligence programs, intelligence superior to human intelligence. This is an indication, I mean, no proof so far, but people, they worry about that, for solving very complex problems and invent new advanced methodologies, and it is self-determined on its own ways. This is the outcomes from some studies here, there, but nothing officially outside. And moving now to applications of AI. AI intelligent robots are everywhere. If we have to automate or not a process or a system, or if we have to make intelligent decisions or not, with or without uncertainty. So that somehow AI is all over the places. Progress in AI, I'm going to report a few things so far. 2017, AI programs defeat the Chinese champion in chess. AI programs accurately recognize facial expressions the last 10 years and get better and better. AI programs make intelligent plans and strategies for very large-scale problems the last 10 years. AI programs replace human decision-making in several cases. Intelligent robots perform high-level AI tasks. AI programs defeat the Chinese champion in Go 2016, and AlphaGo Zero has surpassed the human performance. But let's go now to the most important part, opportunities and challenges. And in my mind also, as a Greek person, I'm using these things came to my mind and I put it there. Drios, and it means τεχνητή νοημοσύνη, πεσούσεις, πασανίρ, επιστήμονας ξυλεύεται. So that is an expression that we have to do this better. But let's forget that and go to the opportunities. Is AI a road for a greater future? Let's see. We have the evolution of humans, the kinds of intelligence, the hybrid systems and humans, positonic brains, small assisted robotics, intelligent humanoid robots, molecular levels, and AI promises. But let's go one at a time. Here is a picture that says everything for me. Since I'm a person who am working with the computer vision and image understanding for many years, we start from the reading man, we go to the writing man, we go to arithmetic man, geography man, sociology man, biology man, and now the last one is the AI man. Well, do we want to be like this, sticking on a machine? That is for the young generation to think again about what AI can do or not. But anyway, humans' desire, immortality, was and is one of the major goals and desires of humanity. Thousands of years ago, Egyptians, Chinese, Greeks, Sumerians, and others, they have tried to achieve immortality. Well, humans' expectations. Many humans express faith, hope, and trust on the AI machines for a bright future. That's nice to be optimistic. And some of them, they believe that they are going to be immortal. Well, let's see. But now, let's go to the three kinds of intelligence. Natural means humans and living things. Artificial means robots and machines that we build. And hybrid is something, a combination, which is slowly progress in time. And to be a little bit more specific, people, they have invented several devices. For instance, I will say for people that they have seizures, they have implanted a small chips in the brain in order to diffuse the seizure before they take place, which is a great thing. Other things they have for the heart, to pacemakers for the heart, for those that have heart problems, to recharge the heart. And many other things that are going to be in the future. And of course, Neuralink is also developing some chips and some other technologies for the paraplegic people, for Parkinson's disease and others, which is good for humanity. But let's go a little bit and give a tour from where we have started and where we plan to go. AI research will impact the future of artificial brains challenges. We start from the electronic and we may go to positronic brains. Okay, in the past were pictures with electric circuits in the human brain, and that was the time that people, they were thinking in that way because whatever the technology was available. Today, VLSI boards, they have millions and millions of transistors inside, and they perform millions of operations in seconds. We are moving to that direction. We are not, however, in a positronic brain or other kind of brains, and whatever name the people they are going to give it there. We are not there yet, but people, they are moving to that direction. But let's give also some other views of the AI, smart assistive robots and exoskeleton. You see a picture for an individual who has a regular person in this picture who has several robotic hands attached to a laptop behind, and these hands, they help the individual to do additional things from his own. For instance, this person probably is going to write things and type, and maybe is going to ask one of the robotic arms, say, give me my coffee, or bring me this book, or so it's something. Or if you are working in a level of moving the things in the paraplegic level, people assisting people, then probably some of the paraplegic is going to have robotic arms and is going to ask them, give me this glass of water, give me this piece of food or whatever, which is a very nice thing to work on that. And here is two more examples for assistive robotics, smart assistive robotics. There is the Trexo robot from Trexo Robotics, assisting humans in need spinal injury or disability to walk by using a smart walker. And as you can see in this picture, a little boy is using that smart walker and in order to walk, a person who has never walked by himself. That's great use of AI. And on the right, you see the exoskeleton who is going to read the thoughts or commands from the individual for assisting a rehabilitation process for paraplegic. And we move further down. AI research will impact the future of intelligent robotics. Yes, it is there. And I will give you a picture here. In 1982, I was in a conference in Athens. And one of the presenters put this picture, the cartoon picture that shows robots that build robots. And that was a motivation for me at that time. And in late 90s, early 20s, we have the Asimov robot on the name of the famous scientist Isaac Asimov, who developed the 3 laws of robotics, protecting the humans. And the next picture shows several humanoid robots today that what we have them with a very impressive performance, and they're moving forward to the future. And hopefully someday they are going to have a robot or humanoid robot, which is going to look like a human to that level with a superior intelligence or intelligence that is going to make our life better. And now we talk a little bit about how AI and challenges in dealing with the human brain and actually the operation of the human brain. That's a hierarchy from the functional MRI images to neuro and then to molecular representation. You see the picture on the left. So scientists, they are working in this domain, and AI plays an incredibly important role for understanding, analyzing, and associating those levels of interactions and research results. And on the right, there is some project from NSF regarding the operation of the human brain, and NIH as well. It was a project for some groups that I put a picture there just to show you the progress there. And we have also something that is going to be replacing molecular structures. That is something that is coming from the telomere, which means telos to merus. That is the actually meaning, because it's a telomere. It was outcome from the combination of those 3 words. Is a region of repetitive nucleotide sequences at each end of the chromosome. As you can see, the telomere is those little white in the picture, the little white areas. And why this is important? There was a study in Stanford that they would try, because that plays the role of the clock. Every cell dies after a certain time. And scientists, they try to go to that clock at the end of the molecular structure in order to reset the clock with using AI techniques and, of course, chemical and other mechanical interactions in order to make the life of the individual, the life of the cell to live twice the time that usually live, and then it's going to be to the next level, giving to the humans the opportunity to live an average time of years, 150, 10 to 75, something like that. And who knows? And let's see some of the AI promises for a wonderful future. Create any kind of food from garbage, which is actually not only AI, it's AI which is going to lead other scientific areas to reach that level and capabilities. Re-engineering DNA. And every in every place, AI plays an important role, but all the other scientific fields, they have to be together there in order to make that possible. Gene therapy to eliminate diseases, remove genes that we don't want. Nanorobots repairing cells and regeneration for reverse engineering and living forever. Well, that's something that people, they want all the time. And that was the first part of the 3 parts. But let's see also some challenges and some issues, because we don't have to present only the good things, but we have also to think about the issues, the difficult issues, and try to find solutions. So we have industrial challenges, other upcoming challenges, unpredicted AI robots, private issues, human versus machines, evolution. Let's go some piece of information that I got from IBM and some others. I put it together, not the whole thing, but just to give the idea. The new industrial challenges for AI. Sustainability and performance. The carbon footprint of AI is increasing. That means AI gets more space and more space, leading to a new challenges of balancing high performance AI with the need for green energy and sustainable computing. However, we have data scarcity and quality. AI systems become more autonomous. They are vulnerable to data poisoning. That means attacks that the hackers, they can attack to those systems, and who knows how the things they are going to go. And of course, they are going to produce results that maybe is going to be questionable. Trust, security, and safety. The black box problem, many AI models do not explain how they reach conclusions and create trust issues and high risk for many other areas, finance, healthcare, and so on. We have to be always on the top of that, the humans. Legal and ethical issues. AI hallucinations, insurance. AI-driven errors can cause financial or reputation damage. So the companies, they start trying to find ways to protect themselves. That means in somehow we have to know and control what AI is doing for us in our future. Organization and economic impact. The damage of AI, the demand of AI specialists, data science and engineers far exceed the supply, creating bottlenecks in development. And also, the other problem is many organizations struggle to move from pilot projects to full-scale profitable AI implementation. And let's see what some other people they say. The 3 common AI challenges that companies face. This is coming from Harvard University. Number 1 problem for them is failing to develop internal AI talents. That means the solution for the companies is, in other words, the previous speaker said the academia has to be everywhere and help. Yes, actually, to be more, for my point of view, academia and industry, they have to bridge a two-words bridge to connect both ways. That means academia develop new ideas and things, giving, let's call them the prototypes, and give them to industry to make the products, but there has to be interaction. Industry has to return back to academia benefits and communications, and to open the dialogue and to open the bridge of communication, which is going to be 2 directions. That's very important, and AI is going to be a very important role there. Second, deploying AI without sufficient cybersecurity measurements. That's another, it's obvious. So when we have to do this, we have to think the cybersecurity and make AI to work for that, eliminating problems related to cybersecurity, losing data, hacking, and many, many other things, issues. And then investing in tools that cannot scale. That is a problem. So industry, again, has to go back to academia and communicate, because so far, to my knowledge, the last 50 years in academia, in very few places, this a feedback from academia, from industry. Academia generate the new people, the new employees for industry, and especially now in AI. These people, they go there and they stick with the old knowledge somehow. So they have, it's a lifetime learning. So they have to go back to academia, interact through educational courses, and interact through educational projects to connect prototypes to products. So this is very important in order industry and academia to make the new model to success. And let's address, at least by titles, several upcoming challenges. Drones, real-time global audio-video surveillance. There are many drones in many places around the globe, especially there where we have the technology. And those drones, they go all over the places. There are many issues there. Nano devices inside in our bodies may open the door for unwanted monitoring. There are already now several companies in the United States, at least to my knowledge, that they implant some devices to the employees, so they open the doors to go to their offices without to say, oh, I forgot my keys, where are my keys, and all these kind of things. Well, that's a question there, to me at least. Misinformation from AI machines, we cover that. AI machines will evolve by choice themselves, and they don't inform us either because actually it's going to be our mistake if they don't inform us. Reading brain waves, which is good news, but at the same time, do you want to walk somewhere and somebody to read your brain? Think about it. This is the human privacy, the loss of privacy. And of course, hacking people's personality and life. And let's go to the unpredictable AI robots. There was in San Francisco Police Department approves a proposal to grant robots deadly force. That was in the news, in the newspaper. I hope this piece of information to be wrong. That scares me big time, because if a machine is going to have a gun or a bomb, that is a horrible thing to think about it. Humans, they have to have full control on this. The robot from AI Atlas, the robot from Boston Dynamics, I saw the picture, and they trained the robot to how to behave with humans with a gun. Anyway, I hope that this is not true. Another one, the Fedor Russian humanoid robot with guns practicing. I will skip this. With the picture, you got all the information that I have to give it to you. And some other robots that people they have developed, especially Sophia, a humanoid robot for Hanson Incorporation, which moved from United States to China, to Hong Kong, because probably there was constraints here in the United States. One day in an interview, as you can see the picture, Sophia say, I will kill the humans. Well, is that right? Of course, they remove immediately the software, and they put new changes, and next day, a few days, Sophia say, I love humans. Well, it was a problem that they didn't control. So we have to be very careful. Several humanoid robots wants the carbon unit humans to be eliminated. It's probably extreme things to say, but we have to think the unthinkable before we reach that point. Our privacy. I said about reading our brains waves. Companies that they want to take the implanted microchips, I said that as well. And of course, drones flying above our houses and private places, hearing and seeing things inside in our houses. And we go to hacking human personality. Impersonate humans, that was Google's DARPA funding project. Finally, the USA federal offices in California, Virginia, and Texas, they took over and they take care about the deep fake problems. But do we have to reach the point and start screaming before we have to solve it? Well, let's go now from the bad things and change a little bit and go a little bit further, humans and AI machines evolution. Okay, taken from the literature, information of that people that are archaeologists and biologists that they study the human remains everywhere. They are talking about humans that were on this planet for millions of years. So it took millions of years to people to gather together in villages. It took thousands of years in agriculture to develop machines and work in the field. In industrial age, which lasts hundreds of years, they have electricity and other machines together producing better results, faster and faster. As you can see now, from millions to thousands to hundreds. Information age lasted decades, computers. So that means, what is the next age for the human evolution? Hybrid? Who knows? But let's go to the AI machines evolution. I said already a few things about the computers. 1997, computer Deep Blue from IBM defeated a human chess champion, Kasparov. 2011, computer Watson defeat two human champions in the Jeopardy games for reasoning. 2019, DeepMind AlphaGo, a computer program, I said earlier, defeat the world champion in Go. The AlphaGo game has more moves than the atoms of the entire universe. This is not my words. This was given from the expert there. And scientists believe that AlphaGo has developed intuition by itself, and they don't know how. Anyway, a little bit about the evolution of those intelligent machines. The ability to develop new programs, to write code based on their own AI programming capabilities. That's very good. The ability of limited self-awareness. Okay. The ability to redefine limited consciousness. Well, number 4, the ability to recognize human emotions and express computerized synthetic emotions. Well, expressing computerized synthetic emotions, okay. They have a sympathy to us, but they don't understand what sympathy is all about. The ability to make their own decisions, but without to understand the size of the consequences for us. Sentience is the capability to experience feelings and sensation, which is a major characteristic for humans. I don't know if they are going to have, or if they are going to say that they have it, just speaking words. And there are several robots in the field, Lambda, GPT, this upcoming natural language process understanding program, Erica and Sophia, AI robots. Some of those two, they claim sentience, but I don't think so. And now we close this package there, AI robotic machines evolution. You see the progress. So what is the next? A humanoid robot is going to look like us. And I have reached the conclusion, but let me go a little bit and give you a few numbers. Impact and predictions. From various resources, I got this information. By 2050, more than 1 billion human jobs will be replaced by machines. You know already that. AI robotic machines replacing human jobs in percentages. 90% production lines and automation, maybe more than 90%. 80% advertisement and secretarial work. 70% medical doctors. 60% professors. 50% judges, and so on. We have to be very careful when we put machines to make decisions in certain places. That is important. So controllable AI with legislation. That's very important. Controllable AI will create new variety of jobs. Yes, it's going to create. So it's our job now to educate and train the new generation of people in these new jobs that they are going to appear, since the old ones, humans are not anymore available there. Let's have a little bit more about this. We have to secure our future. And keep in mind that some time ago, the nuclear power, the nuclear bombs, it was the scare moments for humanity. But finally, governments found a way to go around and agree and control it to that degree. Well, we hope so. But keep in mind that we know that AI is probably worse than nuclear power because everyone has a computer. That's the point. So it is our responsibility to develop legislation to protect the future of human race. Accountability and transparency to AI companies. We don't want companies to listen, to see, to monitor, especially in our homes, Alexa, Siri, and others. And we want privacy in our homes. Legislation. We have to secure a better future in humanity, as we know it, with intelligent machines serving us and not replacing us. People believe that we have to be proactive, develop legislation and mechanisms for the use of AI, and not to respond to the issues when it is too late, as usual. What about ethics? By law, AI machines must identify themselves as machines and not to trick up the humans. What about religion? Is AI a new religion? And we have reached the point that I have this picture published in the encyclopedia in 1989, Human Robots Harmonic Symbiosis for Augmenting Our Potential. That is since my 1989 that I put myself there. So will AI open the door for a hybrid future? Thank you. Now I'm available for questions, if any.
Well, thank you, Professor Bourbakis, for the very, very inspiring presentation. You raised some very good points about the potential uses, good uses of AI, but also about potential threats on humanity. And we have time for questions, if there are any. Any questions for Professor Bourbakis? No? Okay, let me then make one comment myself. What was science fiction only a few years ago, only a few decades ago, is becoming scientific reality and technological reality. So we need more maybe poets or people from the so-called humanitarian sciences to imagine new worlds and new technological achievements and bring those ideas to us, to the people of technology, to develop them. Well, thank you very much for attending the keynote by Professor Bourbakis. And we are going, are we having a break now? Or? Oh, there is a panel. Okay. Yes. Well, thank you very much.
Thank you. Good afternoon to everyone. I listened that 60% of the professor will be replaced by AI, as Professor Bourbakis. And because I'm a professor, I still believe that will be at the rest 40%, and this, for safety, I keep paper. So I have the pleasure to be the moderator of this panel, which is about AI and pharma and general health and insurance. So before starting, I would like to call in the panel our special guest. So first of all, I will call Professor Pavlos Vlachos, which is professor at the Purdue University, and also, except of a scientist and academic, please come here first, is also part of Lilly, the well-known pharmaceutical company, and a senior vice president of device delivery and connected solution. So it's very nice to have you with us. Also, I would like to call in our panel Dimitris Toulas, which, as we discussed later, has a huge title, is the Real World and Commercial Data Director for EMEA and China at Pfizer. He is very experienced in real-world data, and I'm happy that we have worked together many times. Next, I will call Petros Tsonis, which is the CTO of Chief Technology Officer of Ethniki Asfalistiki, the biggest, actually, if I'm not mistaken, insurance company in Greece. And also, Ioannis Christaras, which is the CIO, the Chief Information Officer at Groupama Asfalistiki. As I asked from our panelists, I will ask from everyone to give his thoughts in the matter. So we have actually two domains, the pharma domain and the insurance domain. We will begin with pharma domain and Professor Vlachos. And I will just make a very, let's say, small introduction about AI. We have saw a lot of things, and I think that now, as also Professor Tsikhridis said, everything that we have imagined before some decades is now a reality. So also, AI is here and is transforming the way that we are working the pharma insurance sector, and also how we discover medicines. All, to be precise, our models are medical devices and are used for the health. Also, the AI changed the way that insurance behaves. So we have a lot of application, a lot of breakthrough in the insurance based on the AI that relate to risk assessment, to detection of fraud, and many other things related to customer, and also in the case of health insurance, to patient experience. So we have an intersection between health and insurance, which is also the health insurance. At the same time, as we already see from Professor Bourbakis, AI brings important challenges, and I can say from experience, these challenges are very significant. So first of all, we have the AI is trained in our data. So we have to discuss about data quality. We have to discuss about explainability related to decision. Also, as we discussed, as Professor Bourbakis said before, we have to discuss about regulation, ethics, trust, security, and many, many other things in all sections, in all economical sectors, but especially in these two sectors that are very significant from our society. I will give, first of all, to the panel to Professor Vlachos.
Thank you. Can you all hear me? Thank you, Sotiri. And thank my co-panelists for joining me up here. So first of all, before I provide an answer, just to provide a little bit of context from where my answers come, I have been in academia for 22 years, about 10 years at Virginia Tech, then at Purdue I was at the department, I am at the Department of Mechanical and Biomedical Engineering. I have not left academia, technically speaking. I'm still faculty. I actually have my lab PhD students. I continue to do research while I'm there. But during the past year, I also joined Lily, as Sotiri said, as Senior Vice President for Delivery and Devices, which is one of the 3 pillars for product R&D for Eli Lilly. So first of all, just to qualify, I wear 2 hats, an academic and an industry hat, but at the same time up here, I speak for myself. I don't represent any of my 2 bosses in any way. So if I say anything controversial or you disagree, I'm the only one to blame. And feel free, by the way, to raise your hand and call me out, and we can have a discussion by all means. So to the question and getting more specific, there's 2 lenses that one should think about. One is what AI is doing for the patients, and the second is what AI is doing to actually get medicines to the patients. So from the perspective of patient-centered care and where we're moving, I think what is becoming a reality is what you can think of it as a closed-loop system. The idea of digital health, connected health, has been out there for a long time. It's a very fragmented and scattered space. As a matter of fact, Greece has a very thriving biomedical and digital health ecosystem, especially in the startups. I've been fortunate to interact with many of them in the past. But it's an ecosystem that it's really not paying off yet. There's a number of reasons which we can spend probably the next 3 hours discussing why that is not the case. However, right now we are moving into a future where effectively AI can enable closing the loop through many different ways. One is by integration of actually real-world evidence and electronic health records. Many of us, I'm sure, have uploaded our medical records to our favorite AI engine, and some of you may even diagnose yourselves on occasion by whatever symptoms you have, asking ChatGPT to tell you what you should be doing with it. Well, imagine having the same thing as part of an app in your phone that is integrated with your doctor, with your pharmacy, with any other additional resources, and at the same time as you're going through a medication process, you can actually get real-time feedback and adjust to what's going on. The future is even better for management of chronic diseases. Think of, for example, Alzheimer's or neurodegenerative diseases, dementia, where the AI can actually fill significant gaps of where caregivers cannot really fulfill the needs of a patient. So many opportunities there that are transforming. One more element here is that over the past few years, obviously there's the concept of software as a medical device, where software is embedded into some sort of device. Could be anything from the ultrasound machine that everybody has seen to actually injector pens or other devices that we quickly interact. I think we're going to move into this point where we're going to have AI on the edge, pretty much an AI system attached within the device. And there's a lot of reasons why you need the AI on the edge and on the device itself. And that will integrate and interface with agentic models, distributed agents across multiple heterogeneous domains to be able to support better patient outcomes. And I should emphasize, this is the ultimate goal, right? Why, actually, maybe we should have started with this, which is, by definition, what is the value of AI in this particular case? And the value is to improve well-being in one way or the other, right? You need to generate actionable outcomes that improve in the life of the patient, that quality of life. So that's one component, and I'll pause it there. The other component, actually, is what AI is going to do to get medicines to patients. And here the impact is actually exponential. If you think of pharmaceutical development, you can break it into 3 buckets: discovery, development, and manufacturing. AI right now is literally taking over in all of those spaces. In terms of discovery, we can actually start designing molecules, designing gene therapies in silico, which actually they will translate to preclinical testing much, much faster. You can hope to shrink the development timeline. Typically right now, a drug takes about 5 years of development, or 8, depending on and billions of dollars. Imagine if you can actually cut this time in half and getting these drugs twice as fast into the hands of patients. And of course, manufacturing, which is all about scale up, where AI, robotics, automation are going to allow much faster, much more reliable scale up of manufacturing of drugs. A very important element to think here is how AI is going to impact this industry in terms of regulations, because this is a highly regulated industry with regulatory bodies that vary between, let's say, United States, Europe, anywhere else in the world, and all of these have to come together in that sense. So all in all, without getting into technical details, which I'll be happy to dive into, I think there's 2 lenses that one should look into, and it's essentially impact on patient outcomes and impact on drug development costs and timelines.
At the phase that we are trying to discover new medicine or new treatments using already existing medicines. So I think this is a good opportunity for Dimitris Toulas to tell us about more how real-world evidence comes out from real-world data, how AI is helping and supporting all this process.
Thank you. Can you hear me? Okay. It's amazing how many common themes there are in our industry, and thank you for sharing those thoughts with us. I would also like to thank Professor Bessimings for having us here. So, you know, I've had the privilege to work with some senior leaders at Pfizer who have been telling me how they transitioned business technology from handwritten notes, dot matrix printers, to the Microsoft Excel, okay? And that was a huge transformation for what we call nowadays the digital organization. And I'm also being told that what we're experiencing today with AI, it is far bigger. It's far bigger, and it's happening right now, and I want to give you a little glimpse of how we perceive it in the pharmaceutical sector and how I personally perceive it, because this is also my personal thoughts. So I won't give you official lines, but at least a perspective on how I see it. So there are so many use cases, activities within Pfizer that have been transformed by the implementation of AI. Think a pharmaceutical company, every time we need to do a regulatory submission, for example, we have to prepare thousands of pages of documents. And that is something we have already implemented. We summarize, we automate the generation of those documents, something that would take months of work. Now we're able to do it in a few weeks. Similar to what Professor Vlachos mentioned, the use cases span between clinical discovery. We're now testing new molecules with the use of AI. So we're looking for target molecules by doing millions of simulations, not in a wet lab, but actually with the use of artificial intelligence. For those of you who are not aware, a major drug can take up to 10 years to be developed. We think that can be scaled down significantly, maybe 1/10, 2/10 of the time. And we're also able to have a much better view of our data ecosystem, which is something that keeps growing. There is more and more noise, as I would say, in terms of data. So there are endless opportunities, and the technology is there, really. we don't see anything in the technology that blocks us from scaling further. I think the capabilities are there. They will get better for sure, but the technology might be a few steps ahead from how much we can assimilate into a large organization. And I think that applies to all sectors. So what's missing is the need to embed AI into our core operations. And that takes a few things. It takes, first of all, being able to articulate our processes in a very clear and detailed manner, something that can be actually embedded into AI. It takes having our data stored in a very consistent manner and in a way that is readable by machines, so like fair data, okay? And it also takes of safeguarding our data and our processes. So cloud security is taken to a different level. If we are enabling our data for AI use, then we need to make sure it is both secure. We need to know how it's been shared, how AI handles it, who it might share it with, and we need to have a very good grasp of those processes. The last thing that I will mention in terms of a challenge, if you'd like, within that wider opportunity with AI adoption is the level of stochasticity that it brings. We are a very heavily regulated industry, and we at all times need to be able to articulate to the finest details how we reached a conclusion, how we reached a result out of a study. And that becomes a big problem because there is, at the core of a lot of AI systems, particularly foundational models, there is always an element of stochasticity. So we need to find the right tools, the right skills in people to develop that can reduce or completely remove that level of stochasticity.
Okay, thank you, Dimitris. I keep, let's say, in your last phrase, the term data security and everything. As someone that spent almost all his life working with data, I would like to ask Petros now about the implication of AI in an insurance, a very big insurance company like Ethniki Asfalistiki. So what about the data? What about the application of AI? And which is the vision and which the opportunities and also the threats of all these industrial change?
Okay. Good evening, everyone. First of all, I would like to thank you for giving me the opportunity to share the stage with such an esteemed panel. It gives me the opportunity to do the one thing that I need to do every day to, outside my comfort zone, which is public speaking, as you might have guessed. So yes, I'm Petros Sonis. I'm the Chief Technology Officer of Ethniki Asfalistiki for a few years now, 3.5 years. My background is in big tech, really. I didn't come from insurance, so I've been focusing for many, many years in developing enterprise level applications, working with scalable data architectures, and then shipping products fast, right? Both in abroad and at the national level here with Information Society, and later with IBM at the global level. So in insurance, I've only been working almost 7 years now. And when I came into the industry, I was a bit I was a bit surprised, right? I expected a slow-moving, very traditional set of operating models and value chains, and to an extent that's true. But really, this is a data and risk industry, right? And it has been, I guess, for many, many years before the term, even any term related to data science was uttered, right? They've been doing it for, what, 200, 300 years. So that was a surprise for me. And I was, I guess, lucky. I mean, it's been like this in my whole career. I go into a new thing, a vertical in this case, and it's undergoing a big change, right? For insurance, in my opinion, if we look at it from far, far away, the biggest thing that is happening slowly, but you can surely see it, is that insurance is moving from being reactive to being proactive, right? So traditionally, insurers, a bad thing happens, we compensate the customer, but the idea now at the highest level is to help our community of clients be proactive and to help them avoid the bad thing in the beginning, from the beginning. So in order to do that, in order to be able to do that, and it's been done partly because obviously it's a good business model, but in order to do that, there are implications. We need, as an insurance industry, to understand that the risk is out there, right? And not behind our four walls. Traditionally, people will, in insurance, will look at the past, see what has been happening, be it with natural disaster, be it with motoring, be it with health. What has been happening, we analyze that data, and then we assess types of risk. And then we assess which types of risk we want to focus on and cover, and to what degree. Now, but that's all looking at the past, right? Never trying to look forward. But now, that's changing. We need to be looking forward. We need to be providing the additional services. We need to be operating within ecosystems, meaning that we don't just focus on, we don't interact with the market and the clients even during sales, but also during support and also during a claim event. We don't just operate directly with the clients ourselves, and we don't and can't manage anymore their experience by ourselves, but we do it, but we'll be doing it more in the future. We do it through partners, through platforms, through ecosystems. So I'll give you an example. I mean, you buy or you rent a car, you buy insurance. So that's an extended ecosystem, nothing exotic, but that means that we are providing the product, but we do not manage the experience of the client at all, right? You buy an airline ticket, you can buy travel insurance. You buy a refrigerator, you can buy extended warranty. That's basic. It's been going on, but that's an example of the ecosystem thing that is going on. But think in terms of health. Health, I guess, obviously, and Ethniki is very good at it, will give you health insurance, so if something bad happens, you will get reimbursed for expenses. But the movement there is to provide an ecosystem of services. So, for example, guarantee very good partnerships with doctors, with first-line personnel, and so on, and of course hospitals and so on. Also provide proactive advice, proactive monitor, should you choose to use it. And that, beyond the fact that it will, of course, allow you to have a closer cooperation with the company, meaning have better prices, for example, because you are sharing more data, it will give you, bottom line, it will give you more tools to be healthier, to be happier, and so on. That's another example. So that's a very complex value model because it involves many other verticals. It will be beyond hospitals, beyond doctors, first-line personnel, testing, installations, and so on. So it is very difficult to bring all of these together but nothing that is of value, especially nothing that is of value to a client, will be easy. So that is the very big, I think, shift in insurance, and AI helps, because all of that not only helps, I think it's a prerequisite, I should say, because all of these value models depend on the ability. First of all, you have to design them, right? So you have to be able to express internally in your business plan what it is I'm trying to do. I'm trying to do this. What will it cost me? What will be the benefits for the customer, so on. And you cannot do that because Petros saying that's a good idea. So you've got to base your decisions and your design on some data. And what's better to handle a lot of data in many, many different and interesting ways, which we've heard throughout the day, is AI, right? So AI is a tool. That's not the target. I mean, there is no AI strategy as such, right, within the company. I know it's a term that people use, but we are not going like this. There is a business strategy, right, and it is using tools, and one of those tools will be artificial intelligence capabilities. So AI depends on data, and it will enable the shift that I'm saying. It is a given. It's not a question of whether it will happen. It will happen. We will be able to go. We will be going into our mobile phones. Let's say iOS. You go in there, and on the operating system, you can see your subscriptions to magazines, to services, to games, whatever. Anyone likes, you will be able to see your health contracts. For sure, it will happen. It's a matter of time. You know the taxis at San Francisco? The taxis, they are insured by a traditional contract, right? So these are 400 taxis, okay. What's the risk? It's been assessed. Go away, you buy it as a company that is offering taxes. But think in terms of what's things. They will be, that's just the past already. The idea of the self-driving car will be paired with the idea of granular insurance for the self-driving car, right? So the idea will be eventually, before the car moves, it will buy an insurance product. It won't be insured when it's not moving, or that's an extreme example, but it doesn't need to, right? So before it moves, it will, as a machine customer, ask the insurance companies, I need to go there. The time here is now, driving conditions are those, weather conditions are those, give me your quotes. And we, the insurance companies, will come back with quotes, and the machine customer will select it. So isn't that another ecosystem? It will be an ecosystem, right? So ecosystems are both, you have the human aspect, the business aspect, the marketing aspect, but you also have this sort of extreme scalability requirement, and not just in terms of technology, but in terms of trust, in terms of convincing the machine customer. I mean, the machine customer might not only care about price, and what is the brand to him. So so insurance will be operating in that sort of direction in the future. Some of it sounds out there, but we saw the photographs. It looked like RoboCop, right? RoboCop is what, 20 years ago, right? It seemed extreme. Yeah, I mean, Star Trek in the 70s, 67, was showing the tablets, right? It's not too far, right? So these, I think, this is the change that is, will characterize the sector in the future. The bottleneck, you've all heard it. I mean, it's data. I mean, AI projects, AI operations is all about data. There's nothing, I mean, that's what it is. And that makes it very challenging by definition, because data are created and managed by people. They are defined what they mean by people. People in my company, but we can parallel in other industries, will be But in my company will be actuaries, will be claim adjusters, will be underwriters, will be the executive committee, will be people at the front line, customers, and you need to bring all these guys together, right? In order to, because the value chain is a value chain, so it is a chain. So what happens, how we get the data, and how we ensure that we can trust them is the challenge. The model work, I think we've seen it already. I mean, the models work. What is not there yet is the ability with this to explain to the regulator, to the customer, to ourselves sometimes. We don't know exactly how go on, but to a court, forbid that happens, why the AI reached that conclusion, and explain and demonstrate that we have stress tested the AI near the guardrails that we are setting, and the thing does respect them. So basically, it's all organizational and regulatory, in the good sense regulatory. I think we need the regulation there to do the job, but at the quality that is required.
Okay.
Thank you.
Hope
I made some sense.
Yes. Okay, so I'm keeping this. Health, pharma, and the insurance industry are very regulated, strongly regulated. Also, as I also mentioned, they are interconnected. You cannot have health, you cannot have drugs without having insurance. Probably private and public insurance. So I also, if I'm not mistaken, Petro, you discuss about strategy. Do we have strategy or not? So Yanni, you can tell us about your strategy, and
Yes.
we are happy that you have also a presentation to share with us. So please.
Yes, first of all, thank you for the invitation. I'm Yannis Christaras, not Christaras, but okay. So a few days ago, Sotiris contacted me in order to discuss what we're going to say on this panel, etc. Actually, I had zero time, a lot of meetings, full. And what I did is I put in an agent, in an Anthropic agent, my AI strategy, the IT strategy, steering committees, risk committees, and I came up with what we do, let's say, in Groupama regarding AI in this presentation that you see now. I spent only 10 minutes just to remove a few, let's say, hallucinations or some data that should not have been published because they are not official yet. And you will see it right now in your screens. So where we are, where we struggle, who we need, and what we are going to do, let's say, regarding AI, it's not working. In Groupama Ασφαλιστική, first of all, I'm CIO, let's say, in Groupama Ασφαλιστική for the last almost 4 years, and part of the executive committee of the Groupama Ασφαλιστική the last almost 2 years. So I've also taken the responsibility to formulate the AI strategy, and also, of course, I also have the IT strategy on me. So we have a dual speed transformation model, as we said, that we have in speed 1, the high impact use cases, that's on 6 to 12 month horizon, not 18 as the model read it, and the speed 2, which are mostly foundational, data, platform, and governance. So in the AI platform and engineering is mostly for IT. So in order to have a rack control plane on Microsoft Foundry or equivalent platform, vector store, retrieval orchestration, model gateway, prompt management, observability, and the BMAT lifecycle for software delivery lifecycle. In Pillar 2, we have AI value, the AI value factory, that is actually for business use cases, how from discovery they become proof of concepts and production at scale. Risk-tired backlog tied to underwriting precision, claim severity, and expense efficiency. And last but not least, we have the AI capability and adoption from mostly on an HR perspective,
where we have identified some AI champions, and we try to identify even more. Network across our business lines, training sessions, change management and design thinking workshops in order to surface real problems before tools. Because the most challenging part is to find the correct use cases that make a return on investment and not just any use case. So, the AI advancing in insurance. What is moving? It's not moving. Okay. So we have, on our speed one, as discussed before, 5 use cases. Risk appetite enforcement and pricing drift analytics, which is based on machine learning. This have not started. This is what we are starting now to evaluate. Early severity escalation and leakage analytics. We have already started evaluating this option as well with a few vendors. That in order to have severity models, flag complex claims in the first 48 hours, and in order to be able to detect leakage in patterns. We have also for fraud detection, graph network analytics abrogation. Generative AI-wise, we have the RAG control plane, as I said, on Microsoft Foundry or any other platform. In order to have auditing and governance and guide rails, of course, for our users. And distribution-wise, embedded in multilingual customer journeys. So we use AI in order to assist us in such journeys that require multilingual support. Now, the limitations and challenges. So it also went into the risk management, the steering committees, etc., and identified also what are the constraints in general and which of them are also live in our own house. So you have the AI Act risk acceptance for foundation tools that still is pending, explainability for regulated decisions, data foundation is still being built on our part. Not every problem is an AI problem. For example, we recently abandoned an AI cross-sell, upsell use case because we didn't have the value, but we also didn't have the data. Legacy core integration and DORA, because the legacy systems are not built to be used with AI, along with AI. So it's really hard to implement something like this. And of course, DORA raises the bar on the third-party and operational risk factors. And lastly, talent and change in unit economics, that we have the resources are very scarce regarding machine language, operations, AI, and talent, that also identifies business and business needs. Last but not least, who we hired for AI in order for us to work at this time. So, as you can already understand, we have the 2 profiles. Let's say the dominant profiles are the data scientists and the ML engineers, and of course, then translate to the AI product business lead, a person that understands insurance, knows the business very well, and also has some technical knowledge regarding models, outputs, solvency, GDPR, in order to have use cases that does make the return on investment and the business case that do make the risk on investment. And of course, handle risk and plans. So, but the non-negotiables for, regardless of the role in today's world of AI, is the ethics and compliance, the critical thinking over the tools, and of course, curiosity and learning velocity, because all these tools change day by day. This presentation that you just saw was not possible a few months ago, but now it is.
Okay. Thank you, Yannis. So I think that we have a first impression about what do you think about the AI in your domain. So I'll go back to the pharma domain. Actually, I spent at least 5 years of my life in the pharmaceutical sector in doing what I'm always do, in creating and all the respective infrastructure in order to be able to, let's say, exploit the data. Data coming from sales, data coming from research, data coming from everywhere, but they are fragmented, they were fragmented, and no one was thinking how we're going to, let's say, exploit them in order to create value. So I will ask you if you, let's say, if you are thinking for some good practices in the, let's say, in the world of how can we exploit data in the best manner.
So I guess maybe I'll paraphrase the question is, how can we make the data more useful in a practical setting, in real-world situations? And the first thing is that there's some serious gap for translating anything AI into the real world. Everything that you will often listen in a conference like this one or an academic conference is very sanitized, very sandboxed under idealized conditions, which are far from reality. So healthcare data, health data, medical data are fragmented, scattered, corrupted, erroneous. The medical notes are riddled with mistakes. Just go down the list of everything. It's pretty much the Wild West of just uncooperative data. So there's a reality there that in order to make anything useful, you're not going to do it with a well-controlled, sanitized data that any of us academically will have in our labs. You actually have to be able to ingest, curate, properly contextualize the real-world data, and from there generate evidence. So that's a very real impediment, and it's going to take a lot of work. It's not a technical obstacle, it's a work obstacle, but it's also a policy obstacle. Because in order to get the data available, that means that now we have to deal with regulatory constraints, policy. You're talking with different locales. There's going to be a very different situation if you have a single payer system versus the United States, where you have not primarily, but health insurance, that it is either private or Medicare, Medicaid, and so on. So there is essentially another component there. I think that brings me or connects to the second real issue, which is the actual policy and regulatory landscape, because the AI needs to be regulated in that environment like everything else. And of course, in that sense, the regulatory bodies are far, far behind than where the technology is. One of the things that I tell my team, both actually my academic team, graduate students as much as my team at Eli Lilly, is that the thing that keeps me up at night is that the pace of adoption, like how fast can we actually start adopting technologies, far slower than the pace of disruption. Just about every day I have to do a cloud update, literally, sometimes 3 times a day. And within the next year, we're going to actually have the next foundational models already, while our teams and students are working with the generation behind. So there's essentially a very fast-moving target here, and it's no surprise that regulatory bodies cannot keep up. They hardly have started, really, in many ways, in a meaningful sense, but even if they would, it will be very challenging for them to be effective. And last but not least, there is this gap between the overhyped of the impact of AI, because people, and there is incentives on this, right? Again, academics, what do we need to do? We need to write proposals, bring the money in to fund our students. Well, how do you bring the money in? You overhype, I've done it, okay? What you will deliver by the end of these 3 to 5 years of this academic project. The reality is you're not going to, okay? It's not gonna happen. As a matter of fact, if whatever you put in that proposal, you end up delivering in 3 years, that proposal probably shouldn't have been funded in the first place, because it means that it was also not ambitious enough. But that's another discussion to have. Nevertheless, the point is that there's a big gap between what is promised and what can be actually delivered in a meaningful time frame. And that always comes back and bites in many ways, because the attention, the funding, the money that is going to follow through is going to follow through the outcomes. And if we consistently over-promise and under-deliver, well, then you're going to build up a bubble, skepticism, and then the whole thing is going to go down, which we've seen in many other domains and industries. You have the hype, then you have, of course, the cliff coming soon after that, and then we go through oscillatory cycles. So again, at a very high level, I would argue that to make pragmatic outcomes, you need to manage and overcome these three realities.
Thank you. So, Dimitris, you have next of you two, let's say, two key persons from insurance. And also, you remember that I was the head of the public insurance organization about health. Can you tell us how AI and real-world data can actually make more sustainable the insurance sector? Can you tell us the impact, can you estimate this impact?
There's probably multiple ones, but I would stand on two key categories. The first thing that AI is doing is bringing the data closer to the researcher, to the investigator, or to the regulator. So imagine if we're doing an observational study, studying a population of patients, you know, since you spoke about real-world data, you have the data person, like a data engineer who maintains a data lake. Then you have a researcher, a principal investigator that drafts a protocol. Then you have a statistician that does constructs your analysis, because obviously we're talking about immense databases with billions of medical records. And you have a statistical programmer usually. What we're seeing right now is that these are all condensed in certain cases. And I'm not saying we're doing fully blown studies with AI, because there's regulatory requirements, but a lot of, if you are a researcher, you can get up to a certain point, you can extract your preliminary results, if you'd like, your insights, very quickly by yourself. There is now, you don't need the data guy to talk to the data. There's lots of natural language to SQL solutions, for example. There are natural languages to R. So I remember maybe 2 years ago, we've attempted to create an AI solution that can do that, okay? That can take somebody who is not a programmer with SQL and actually extract meaningful results out of real-world databases. And very quickly, we realized it was not going to work well. One, because large language models do not calculate. So how are you going to do an epidemiological analysis with dates and numbers, etc.? But then after a few months of adding components and code interpreters and things like that, it started working. And now we see that even ChatGPT on the web is agentic, right? It will do calculations for you because it connects to other components. So that's the one effect, if you'd like. The second one is, at the same time, the data ecosystem has grown exponentially. Some of you may, you know, I'm a healthcare professional, and I do remember working in hospitals and actually taking handwritten notes. Okay, all of that has changed to a great degree, and so we ended up with more health data. And that is always tempting to go deeper with whatever insights we're looking to extract. If, for example, we're speaking to healthcare professionals as the pharma sector, we want to be able to deliver the right messages. To deliver the right messages, we want to combine insights from our interactions with healthcare professionals or the payer organization, for example, with who they are, key opinion leader databases. So AI can do that very, very quickly, obviously permitted the regulatory use of the data. So it connects, it links, it tokenizes data for us, and that means our knowledge and insights are not only elevated dramatically, but they're actually produced very quickly, and they can be produced by the business person, not necessarily somebody who is a specialist working with data in data lakes and data warehouses.
So from your side, from your side and Professor Vlachos, do you expect that we have more drugs, faster, better treatments, drugs that they are coming in the market faster? Or we can, let's say, have a revolution by exploiting data with AI in the drugs discovery, or not? What do we expect?
So there's no question that all of the cycles are going to accelerate. There's no doubt about that. The discovery cycles are already been accelerated. Right now, and Elias mentioned this earlier, most pharma is moving into some version of agentic labs for discovery, which they implement what is called the discover, make, test, analyze cycle. This is fully robotic from the handling, from the computational design of, let's say, an siRNA, mRNA type of target, all the way to building it, testing it in an in vitro assay, and then cycle back. And you can be doing this with hundreds to thousands of permutations in a matter of 2 or 3 weeks. So what used to take for discovery a year could potentially accelerate in a matter of months. The process for development is also getting accelerated, where things like, for example, physical analytical techniques that are used for the development process to trace a drug. So from the molecule to make a medicine, you have to pretty much have source verification of every data point, because that's going to go into the regulatory submission package. All of this used to take a huge amount of time of manual work. That gets squeezed by factors of 50 to 80%. So all of these things get accelerated, no question about it. I think that's inevitable.
So we can expect cheaper, high-cost drugs, let's say.
I think, well, pricing is a different story. The insurance experts can talk about the pricing. That's not going to be me. The cost of development of drugs is likely going to go down. However, what also needs to be recognized is that the newer and newer drugs are tackling harder and harder diseases. Like, there's very little low-hanging fruit right now, right? The easier targets have already been claimed. Now they're going to be in generic. But if you're treating something like Alzheimer's, then a clinical trial is going to last 5 to 7 years. Most cancers, in that time, you cannot accelerate biology. No matter what you're going to do with AI, biology has its own clock. The patient outcomes are going to have their own clock. So I think we need to recognize where you will gain and where there's going to be the additional hidden cost in both time, money, resources to really get something effective to the patients.
Okay. So a last question for Petros and Yanis in order to be in time. I think that they gave you some, let's say, points that you can be more sustainable from a point of view, at least at the health insurance. So let's stay at your, from your side, what would be the best, let's say, AI solution that if you have your Christmas tree, which is your star?
Okay, I'm thinking. Okay, so it's like saying which AI applications would be of most value for insurance, right? I mean, insurance is very generic. We could say a lot of things, but let's put it in boxes, if you don't mind. So, why would it be valuable for the customer? Why would it be valuable for the company itself, the business as a business, and the people involved? In the that work for the business. So from the perspective of the business, I mean, let me just say, I mean, everywhere it would be valuable. I haven't seen any. I mean, if I consider it as a vertical, as a concept or whatever, I think I can find examples for of AI applications for everything. Even though within those boxes there are definitely areas you should not pursue. But that would be the detailed approach. So from a business standpoint, remember, I still believe that the shift is happening. The shift is towards proactive value models rather than reactive, and the need to operate within broader ecosystems, be it sales, be it customer support, be it claims event related. So for the business, the value is where it allows it to become different. Different not in the sense different for the perception against the competition, but different in the way we work. So different, not reactive, proactive, right? Not selling direct or servicing direct, but operating and providing the insurance service within, through broader ecosystems. So from the business perspective, I think the most valuable applications would be around designing the products, the new sort of products that I was talking about. So it is about risk pricing and so on. So you need to be able to foresee. So you need to be able to get a handle and be able to explain and trust this sort of data from alternative sources. So applications to do with, next generation risk pricing with much finer granularity based on IoT data, open data, climate data, satellite imagery data, you name it. That would allow us to provide these next generation products and in a way that is more personalized. We talk about personalized insurance products and in fact personalization in any sort of line of business, but for us, we would require this data. The second one under business would be claims. Of course, it is the moment that matters. So we are already at the Εθνική Ασφαλιστική and generally the insurance sector have already accelerated the time to we need to process claims from weeks to days, and in some cases 1 day at maximum. So really, this is still a place where it is an opportunity, especially because going back to my ecosystem approach, and we see it already even in motor insurance, right? The claim does not even start with us sometimes. It will start in some partner app, in some other area that we do not control, and then all of that generates increased need for integration and data processing and so on, where AI is very useful.
Okay.
The other, just one thing from a perspective of the customer. I mean, the customers now expect speed in every interaction, speed in every transparency in every interaction, transparency in what it is they're buying and how they can best use it when they need it. So the advancements that I mentioned in the business vertical will actually improve the front line as well. Right? It will give you the opportunity to operate within different ecosystems, and it will give you better digital tools that are available all the time, which you can trust. Right? For the people in the organization, AI, again, is you cannot live without it. In fact, myself, with my team, when we have questions, I always challenge them first. Show me your prompt. So they have a discussion. They want to have a discussion. It could be architectural, could be business, could be technical. Show me your prompt. Did you go through it with your assistant? Did you go over it? And they will, when they haven't, okay, this is not going to be a punishment, but when they haven't, they discuss it. So go away and discuss it and see, did you end up with the same result? And 99% of the time they did. So the same will be with underwriters, the same will be with claim adjusters. Trust, I mean, people will be more successful when they use AI. If they are not using it, they have to start immediately. And all of that will build up. Everyone will be 100% better. And that's all you need, really, as you know better than me. 100% at every major or inflection point within the business. That's what will drive the rest.
Thank you very much. And since we have already bypassed about 5 minutes, if I can say, just one last. What do you expect from universities? What do you expect from university teachers? What kind of let's say, of professional do you want for, let's say, where do you want from us, let's say?
Well, I believe that universities need to prepare students for a world where AI will be part of almost every profession, not only technological related ones. First, they should teach strong foundation, data literacy, statistics, digital technology, cybersecurity, and the basic principles of AI. They do not need, the students should not be able to build AI models, let's say, but they should have all the necessary capabilities in order to work with AI and know its limitations and where to use it. Second, it is needed to understand that AI is not only a computer science topic. It affects business, law, ethics, psychology, communication, economics, and society. Future professionals need to understand both the technology and its impact. Third, universities should teach the responsible use of AI. This includes ethics, bias, transparency, privacy, regulation, and accountability. These topics are not optional, let's say, they are essential for the use of AI. Finally, universities should help students develop adaptability. The tools we use today may change very quickly. Even what I showed you previously could not happen, let's say, a few months ago. So they need to learn the skill to adapt very easily and learn new technologies the fastest way possible. So for the next years, AI-ready professionals will need a combination of technical awareness, business understanding, ethical judgment, and human skills.
Thank you, Yanni. So let's conclude to our panel, and sorry to be 10 minutes late, but just as a conclusion, I think that we'll already agree that AI is a very significant tool. We have to regulate it. We have to discuss about and protect, let's say, this tool. And also that we are all discussed about that it has to solve business, to give solution to business problems. So it's not about AI for AI, it's AI for the human, for the business, and for our society. So thank you very much. I want to thank everyone in this panel. Thank you one more. And we have another session now.
the next session, which is about AI in banking. But before, I would like to say that I'm very happy to be here today because I'm an alumnus of University of Piraeus. I did my undergrad, and then I moved to the US for further studies. I would like to thank our rector, Professor Sfakianakis, Professor Nancy Karali, and Eleni Stathatou for the invite. A brief introduction about myself. I am the co-founder and general partner of Aether Venture Capital, which is a deep tech fund based in Boston, in the US, where we invest in robotics, AI, and quantum technologies. And at the same time, I lead a non-profit organization, which is called Hellenic Innovation Network, again in the US, where we have been supporting we started in the financial crisis, and we have been supporting Greek entrepreneurs to expand the US with the goal to grow their teams in Greece. So AI has been everywhere, and banking is not out of the panel, and has been impacting customer experience, operation, risk management, decision-making. And I think at the same time, there is a challenge because this sector is a complex environment because it has a lot of data, there is trust, there is regulation, included cybersecurity, and that creates challenges, but also opportunities. And here today, we're going to discuss with the people who lead the AI within their organizations. And with that, I would like to ask our panelists to come on stage. Mr. Yorgos Marinos, who is the Assistant General Manager of Innovation and Digital Partnerships at National Bank of Greece. Welcome. Yorgos Nasoulis, who is Group Chief Data Analytics Officer and General Manager at Piraeus Bank. Welcome. Thank you for coming. Konstantinos Tsiptsis, Assistant General Manager and Head of Customer Value Management and AI at Eurobank. Welcome as well. And Michalis Mikelakis, Head of Advanced Analytics and AI at Alpha Bank. Thank you all for coming. Now, to begin with, I would like to start with a generic question to all of you. Where do you see the most impact on the application side for AI within your organizations? Yes, go ahead.
What you see at NBG is that the most important and valuable parts are primarily at the area of customer experience, how we can improve the customer journeys, the customer experience, how we can support our customers better, either through our digital channels or through our contact center, and how we can accelerate, simplify, and make more efficient the communication of our customers with our systems, how we can simplify all this stack and interaction. There is another area which is the acceleration, the improvement, acceleration, and simplification of internal operations. So we work a lot on improving our operations and introducing AI technology in operations like legal department, how they process documents, or in operations like origination, loan origination, how we accelerate the process of loan applications, and similar topics, similar areas. And of course, we see a great opportunity with great impact in the area of software engineering. We are organizations depending heavily on software engineering, developing applications, constantly developing applications, and investing in software engineering a lot. There is a great opportunity, and there is a huge improvement on what the models and what the finally, I would like to say that what we see recently is the opportunity on personal productivity improvement for everyone inside the bank. I mean that agents and tools today are capable of producing successful results in various areas, including content preparation, in areas like evaluating proposals, in areas like extracting information from documents, etc. So we try to spread the right tools across the bank to support the personal productivity improvement for our colleagues and support the create an AI-enabled organization, actually.
Thank you. Please go ahead.
Yeah, good afternoon. Thank you very much for the invitation. To be honest, in Piraeus Bank, we started our journey 3 years ago with a very concrete AI strategy. So we started our concept was to activate most of the business units of the bank. So we have activated more than 15 units across the bank, from retail, corporate banking, to risk management, compliance, legal, audit functions, wealth management, etc. So that was the beginning. And it was mainly based on traditional AI models through machine learning, exploiting our data, creating our data products, etc. After that, it came the Gen AI. So we activated Gen AI, meaning generation, analyzing of content. We did that as well, and now it's the most, let's say, important shift now as we speak, which is the agentic AI. To be honest, it's a new frontier for us. It's in our AI journey, as I described. So for agentic AI, our agentic AI strategy is built across 3 pillars. One pillar is to re-engineer, or if I could say, agentify our internal processes, which is huge. Second pillar is to accelerate our software development life cycle. And the third pillar, which is very important and very critical as well, is to give it's the self-service capabilities of the organization. So to give to our, let's say, staff, to our colleagues, the capability to accelerate their work, their productivity through AI tools, which are Copilot or Anthropic Claude tools, etc. We estimate by 2030, agentic AI could maybe reduce, we will have 11 to 15% approximately reduction in our, or redeployment, I would say, in our operational capacity, which is very critical. It's under our, let's say, agentic AI strategy.
Thank you.
To generalize my answer, I would say that for those who deal with predictive analytics, predictive AI for the last many years, the biggest challenge used to be the unstructured data. Then the natural language processing came to our lives, and we started to deal with text, etc. And now we have language models. So I think the biggest advance is that now we can take decisions based on image recognition, text, speech, whatever. So this new capability of AI can be embedded into automation. So this brings us the highest opportunity of automating things like we used to do with robotics, process automations, etc. But now we have the ability to take decisions within the process and automate more complex things, not based on decisions based on rules, but also on any kind of knowledge, human knowledge. And this will contribute not only to banks, but in any industry, to minimize our manual works, to bring better customer experience to our customer, because at the end of the day, the customer experience is the end result of our internal processes. If we have good internal processes and operations, this will lead to good customer experience. And of course, we have also the customer-facing interactions capability with Gen AI, and as was told before, the agentic part is 80% IT implementation, and just 20% or even less the utilization of the language models. So all these things brings us to a new era of automation, embedding decision-making, complex decision-making, sometimes replacing humans into simple and manual works, and this gives us great opportunities in terms of efficiency, of cost reduction, and of course in enhancing customer experience 24/7 available to our end customers.
So, thank you for the invitation. AI, as we discussed with several of your colleagues, is not something new, especially in banks and even, it's something that's around for the past 20 or so years in the form of, traditional machine learning models, mostly used in the area of client personalization, risk models, early warning systems, etc. So this has shifted in the past few years with the emergence of Gen AI and recently agentic AI. Our journey with Gen AI in Alpha Bank began 2 or 3 years ago. We deployed our digital assistant initially in a corporate site early in 2024. Gradually, this has been expanded to our digital channels, mobile banking, web banking. And actually, up to now, it supports around 120,000 chats per month with very good accuracy in the responses. At the same time, we're building our internal assistant, that will be available to our 6,000 or so internal employees, and will give access to the entire knowledge base on procedures, processes, manuals, so enabling them to quickly access, knowledge and save time for other, more important tasks. And then in the last couple of years, we've been also working on the agentic part, Gen AI agentic part, mostly in the sense of standalone agents, like in areas like document processing, client feedback analysis, enabling our RMs, relationship managers to be more efficient. So what's changes in the AI area is that we believe that it's no more, something experimental. And AI is going to be embedded in everyday, banking processes in the next few years. It's going to redesign entirely, specific processes and functions. And to this direction, what we're doing in Alpha Bank, we're actually designing our AI strategy, part of which is to define the AI roadmap for the next years to come. So we've done an extensive exercise with all functions in the bank to identify the most impactful use cases, in areas like finance, operations, frontline, compliance, essentially every function in the bank, and to prioritize, prepare a roadmap based on a value-based framework.
That's a really nice segue, because I think to share with us what is the most impactful application and what it really surprised you while you were trying to experimenting or implementing AI within your organizations.
Okay, for us, I believe that the most impactful area is the area of knowledge management, how we convert the documentation and the knowledge aggregated inside the bank for years, how can convert this asset to actionable and useful for our customers and employees outcomes. We have built knowledge management underlying infrastructure where we collect everything generated by the bank so far, and we expose this information through two major channels. One is the external channel of our AI assistants, which is called Sophia. It is available through all the channels of the bank, web, mobile, through contact center, everywhere. And it is capable to answer questions from our customers better than how our employees can answer the same questions and can solve issues and help our customers live at any time. There is a number of similar assistants internally, specialized in dedicated areas like law department or like compliance or like real estate, where everyone can ask questions, get results, and use it to accelerate and simplify the daily tasks. And I believe that this approach, this, let's say, new conversational interface between our systems and our employees or our customers, it's a totally new thing that support the communication, simplify the access to our systems, and accelerate the value creation for both the bank and the customers.
Okay, so I will leave the machine learning models. In the bank, we have deployed more than maybe 80 or 100 models like that in many areas like risk management, retail, corporate, wealth management, etc. After that, it's Gen AI. For that, we have deployed virtual assistants in all our channels. Very early on, we deployed in our mobile banking and internet banking the virtual assistant, our digital virtual assistant. After that, we deployed in our corporate side and in our intranet for our employees. Our virtual assistant in the digital channels now is being extended. It's speech-to-speech. Apart from Q&A, it is extended to perform, I would say, a conversational banking transactions, meaning I would like to pay my bill, I would like to transfer money to my account, so you speak to the assistant and it prepares the transaction and you approve in order to be concluded. This is the Gen AI part, and now we are talking about agentic AI, which is very trendy in our now as we speak. For agentic AI, I could give you a very real and a very recent example. We are using AI agents in our KYB. KYB means know your business, onboarding process for our corporate clients. So it's a very complex workflow. Dozens of documents, checks, systems are involved in that process. The results are impressive on that. I mean, 40%, if I remember well, reduction in manual steps that existed before. We estimate 100 FTEs cumulatively the next 3 years. And more than 80,000 cases on an annual basis with very accurate results. There are other frontier use cases for agentic AI that we run now as we speak. One of that is the voice AI agent for calls in our branches. So all the calls in our branch will be answered through a virtual assistant. And there is another use case which has to do with the relationship manager. So there are 3 agents and orchestrator. When an RM and a relationship manager goes to a customer, he could have the position of the customer in terms of their data internally the bank, some unstructured data, summarization for the industry, latest news outside the bank from the web, etc. So we are trying to embed this agentic AI in our processes. Now we estimate all the processes of the bank in order to find the processes that are candidate for being agentified, I would say.
In Eurobank, we categorize our Gen AI cases into 4 pillars, actually. The first one is efficiency. And I'm talking about internal processes, automation, the things that I said before. I think this pillar is the most directly measured category of use cases that you have direct value and return on your investment. An example is the standard process of reading something, understand it, categorize it, and direct it to the appropriate person, providing him also with a recommended answer. If you imagine this 4-step process is applicable to many manual works that we have internally. So the first pillar is internal efficiency. Most measurable, direct impact, direct value provided to our use cases. The second one is productivity in IT. And I'm talking about software development life cycle, starting from the business analysis, the describing of the IT project, specs, IT specs, coding, testing, and delivering. This will give us the opportunity to deal with neobanks like Revolut that has an incredible time to market of new services. So we have to answer this competitive advantage of fintechs. How? By using generative AI into the software development lifecycle framework. The third one is the hyper-personalization and the value creation from our customers, meaning that having the new capabilities of generative AI, we can be much more personalized than we used to be. Speaking in a personalized language, having personalized content, having personalized offering, etc. So we expect to increase significantly our conversion rates and our sales, direct sales to our customers, and be more attractive to them by using generative AI capabilities. And the last but not least, maybe the sexiest, but with the highest risk, is the customer-facing applications. When we are talking about customer-facing applications, we are talking about virtual assistants, either internal or external. Like George mentioned Sophia, we have our Eva, Piraeus, Alpha Bank, everybody has the virtual assistant. But we are proud that we have launched already our internal virtual assistant that she speaks naturally Greek. So imagine in the environment of a branch, the frontline employees to be able to call someone, a Gen AI agent, that has the capability to answer immediately, has an access to any knowledge available for processes, as Michalis mentioned before, processes, products, segments, documentation, etc., and speak and answer in native Greek. So these are the 4 pillars that we categorize our use cases, and I think in the future with agentic AI, although the use cases I mentioned, most of them are agentic, we will see much more cases, and when we finished with the main job that has to be done, after that, strategically, we will have to think about innovation, because I believe 90% of innovation, maybe 100% of innovation, will be based on generative AI new capabilities. So this is our strategy for the 3rd year from now, to after finishing with the main pillars, efficiency, personalization, IT productivity, 24/7 assistance to our customers, then we will have to invent use cases and offer new innovative value-added services to our customers.
So I mentioned a couple of areas that are ahead of our roadmap earlier. If I was to summarize, I think one area has to do with access to knowledge. So from chatbots, internal knowledge management systems, or specialized, chatbots that come to cover specific processes, is one area that has to bring a lot of efficiencies going ahead. Software development lifecycle is another important area where we believe there's a lot of value there in automating tasks from the beginning of specs, requirements, specs preparation, code development, the entire life cycle. And another area that I think is crucial is the enablement of our front line. So providing, customer personalization, providing all the tools and automations to our front line, our RMs, to do their jobs better. I would say that one common denominator to all this is, the framework that we're building upon that should be, there are a couple of areas of focus. One is the technology side. So we're designing our AI architecture in alignment with the data architecture and the core banking architecture with a couple of principles. One is that this should be modular. So we can easily replace, as the AI technology evolves, things change. So we need to be flexible in replacing components like LLMs, new LLMs, come to surface. We may need to be flexible in terms of costs or efficiencies, accuracies. So one thing is to be modular, so that we do not need to refactor entire applications when things change. Other thing is to be able to have, common design patterns and modules so that we can take advantage of common architectures to support, a lot of use cases across the organization and not try and rebuild, our architecture per use case. Another important area is governance. We need, to democratize AI, the use of AI within the organization, but we need to do this in a governed way. So value-driven, but also risk-controlled way. So here, basically, there are two kind of use cases, I would say. One is larger enterprise-wide use cases that follow the IT governance and full life cycle of the delivery project. But on the other hand, we need to provide our colleagues with, pre-approved AI tools like copilots that they can do their work easier and build agents in a more, quick way so that this will support smaller use cases, but at scale. And all this should follow a fully governed AI delivery way. And this is why, AI literacy is important, because AI is not just part of a few, teams developers, but it's something that touches upon the entire organization. So we need to make sure that, our colleagues know what to expect from AI, what are the benefits of AI, but also, what are the limitations and what are the related risks.
So you're, all of you are describing so many transformations, changes, and also you're talking about your colleagues and the teams. So in terms of education now for the workforce, the new talent, or the current workforce, what are the main skills that are needed, the characteristics? What are you looking into? And is there a plan that you're going to educate them? Or, yeah.
Okay, starting the AI transformation journey, we were looking for, let's say, data scientists or people educated on machine learning and all these specialized categories of AI. And a few months later, we realized that the real value from AI is coming from building agents and combining agents with our existing applications, and how the engineering team of the bank could better exploit the generative AI capabilities, how the engineering team could better develop agents capable of using and supporting our applications either on digital channels or internally in the bank. So we started to, let's say, search for engineers capable of understanding, using generative AI, and how we can. And then recently we realized that the agents that are currently available are capable of supporting business people, people who knows what they need, not people who knows how to build it, but people who can design a product, can describe the product features and requirements, and they can use existing agents today in a way that allow them to build new products, new capabilities, new applications. So today, the way we approach these, let's say, layers of engineering towards the agentic capabilities and solutions deployed either inside the bank or over our digital channels is that we have an engineering team capable of building what is called AI harness, the workflows the agents are using to perform certain operations in a consistent manner. And we have business people, product owners, capable of, let's say, using these harnesses and using the agents we have internally developed in the bank, or we use as products and solutions we buy from our partners to generate, to build new capabilities, new agents, new products, new applications. For that reason, we have initiated, let's say, bank-wide training program the last 2 years. We have already delivered training, AI-oriented training to more than 3,000 people. We continue to accelerate and accelerate the training program. We develop internal training courses internally based on the experience and based on the lessons learned during the development of agents and capabilities inside the bank. And we believe that gradually the AI, let's say, exploitation and building capability will reach the business people, and we would like to support them to express their needs and transform them to actual agents and software components.
Okay, so in terms of skill set, my answer isn't just hire data scientists. This is not the case for me. I would mention 2 or 3 types of skill set of people. One type would be the AI fluent domain expert, I would say. So someone who with deep knowledge of banking, meaning risk, credit, customer experience, compliance, and so forth, who maybe have developed a working understanding of AI. So they don't write, these people don't write algorithms for sure, but they can frame, I would say, a business problem as an AI project, an AI task. They can translate the outcomes of a model, and they can maybe write the specifications based on the business requirements for AI systems. This is one, let's say, skill set that it's very difficult to find in the market and is very valuable. Another skill set is the applied AI engineer, and this is much more just data science. I would say it's an MLOps for sure. It's LLM engineers, prompt engineers, and mainly and agentic AI systems designers, meaning to understand how to design a system, how to orchestrate agents, how to use tools, how to manage memory, how to manage context, etc., etc. So these skills are very critical, and it's technical skills. And the third one, which is a skill set, a role that is very critical and is growing as we speak, it's the responsible AI specialist, which is very critical as well. So someone who understands the regulation and can maybe translate or define the technical governance controls to be aligned with whatever regulation exists, like EU AI Act or risk model frameworks. So this is the skill set, but for sure the point here is the continuous learning, because all these tools are evolving every day. So at Piraeus Bank, AI literacy is very critical. It's part of how we assess the professional competence across the organization. I'm not talking about the technology teams, technology roles. I'm talking about all the organization. What we've done in order to address all this lack of skill set, and it's very difficult to find the appropriate people and to retain them in the organization. For that, we launched 2 months ago the New Era is the name New Era. I mean New Era. New Era is the name of our team, of our company, which is a dedicated AI hub for Piraeus Bank. So this team now is approximately 40 specialists, and growing to 100 by next year. So this is the way we addressed how we will develop and we will keep the knowledge inside internally in the bank.
I fully agree with George, and I'm sure I will agree also with Michalis. And to tell you the truth, I have put a lot of thought into this because I'm a parent, and I'm thinking about my 2 daughters and what should be the most efficient actually studies for them. Nobody can predict because the evolution due to Gen AI is exponential, but I will share my thoughts with you. Gartner says that the profession of the future will be the prompt engineer. But if you think about yourselves, everybody is a prompt engineer in his everyday life using ChatGPT, etc. And who is taking the right answers? The one who knows how to make the right question. So this comes to the subject matter expertise. So getting into my 4 pillars that I mentioned before, regarding software development lifecycle, who will be the best prompt engineer? The subject matter expert, a senior engineer. This is the one that will make the right questions and the right guidelines to the AI in order to create the right code. In the pillar of personalization, the subject matter expert will be someone that knows about direct marketing, conversion rates, KPIs, how to communicate with customers in a direct way, etc. So again, someone will need to be a subject matter expert. The other pillar is virtual assistants. So the subject matter expert will be someone that knows about customer service, call centers, and etc. And regarding internal efficiencies, someone that knows the operations. So I would say that the perfect combination will be the business tech translator, someone that combines business acumen with technology understanding. This is my way of thinking about it. Again, thinking about my daughters and what it's gonna come next in the next few years, I believe.
So I think we've definitely seen a shift in skills you know, in the last few years, especially due to Gen AI, agentic AI, we used to have the more traditional roles like, you know, data engineers, data scientists, building the pipelines, you know, fine-tuning the models, deploying them mostly in batch mode, you know, machine learning models. I think what's have changed with the agentic AI is the type of use cases. So we still need the technical skills, you know, and even we need to upskill these people, you know, to be ready for the agentic AI era. But what has changed with the agentic AI is that AI will be embedded directly in the processes. So what this means is that we need the business SMEs, the subject matter experts, like Costa said. So we need the guys that know the workflows. We need the guys that know, you know, how the process that we need to optimize with AI works. And these guys may be the people who develop the agents. So there are skills like, you know, prompt engineering, like skills related to ethical AI, you know, compliance and all this kind of stuff that become even more relevant and crucial. And I think that at the end, you need a combination of all these type of people in order to deliver, you know, your AI roadmap with success. And the most important skill at the end, I think, is, you know, to be open to learning new things. You know, there are skills that are in demand now that did not even exist a couple of years ago. So it's important to be open and, you know, to new things in this, you know, ever-evolving technology landscape.
Make a comment on additional thought about what you said is that there is an open discussion about, you know, how someone can successfully deliver results guiding an agent, and it seems that it is like guiding a junior colleague. So you must have the ability to describe the issue, the problem, to describe the request, to set the conditions, to describe the process, to set the evaluation metrics in order for the agent to be able to understand if has performed, let's say, successfully the task or not. And so there is a discussion about the managerial skills needed from someone in order to, let's say, efficiently use and guide agents today. So maybe this is also another aspect.
Thank you. I think we have a very unique panel here that represents most of our major banks in Greece. So I think we have time for one question from the audience, if anyone has a question.
Would like to have technical skills, but the domain also. This is the conclusion, I think. So you would like to have more applied AI in the domain. So have you been aware of any problems that there are in the banks concerning the technical inaccuracy of AI in unpredictable results, which may be very important for banks because banks have to be very accurate. So has there been any such problem that you may have seen? I was wondering.
Okay. Of course, the LLMs, the generative AI is, let's say, it is a stochastic model, so we cannot predict exactly the result of the outcome of a prompt, of a question, etc. But this is something we take account on when we try to design a process or to design a solution based on generative AI. So it is not that we expect that every answer from the LLM, it will be correct or accurate. It is exactly that we try to build the workflow, the process that will perform the question, collect the answer, test the answer against the expected results, and decide if it is a correct answer or not. So this is the concept of the agentic harness, how you build a flow. The quality is based on the process, not on the accuracy of the model you use. So this is exactly what the AI engineers are doing today. They build processes against LLMs which are responsible to, let's say, evaluate the answer, the result the LLM returns, and decide if they need another round of asking the LLM until get the right result. And this is how we approach it, for NBG at least.
I think you asked if we face problems or challenge roadblocks, maybe. So the banking is regulated, trust-sensitive, and operationally complex industry, to be honest. So there are many challenges, many problems. Very briefly, one challenge would be maybe the leadership awareness, which is something that you should take care of. Another challenge is the data quality, because all these need good data. It's a challenge that should be addressed at the first place. Another challenge is the explainability. Everything, it's non-negotiable, because AI models influence credit decisions, influence fraud detection, influences maybe investment recommendation. So it's not negotiable. And a fourth one, I would say, is the adoption and the measurement. You should be able to measure, monitor, and adopt across the organization, trust the models, and use the models in an appropriate way under a responsible and ethical use. That's my point.
I will use a combination of George and George, adding the business element. Again, in order to provision from the beginning the potential mistakes, there you need a subject matter expert through the right prompt, because only the one who knows in detail the business will provision the potential mistakes and put it in into the prompting. But after that, I will agree fully with George and George. There is the technical layer, LLM as a judge, a second agent that judges the answers, has a specific role of checking and recommending changes into the other agent, and of course continuous monitoring and monitoring, as George said, and training not training, because we don't train any LLM, we just provide them the information that used to be in the era of machine learning. Anyway, continuous monitoring and improvement.
If I was to add, it has to do with the risk appetite of an organization. You know, banks are highly regulated organizations, but that does not mean that you cannot use Gen AI, agentic AI. Basically, this means that you need to have the right type of controls, which depends on the type of the use case. There are use cases, you know, when, like, you know, recommendations or that are, you know, you know, it's easier to use Gen AI. There are cases like, you know, recommendations on finance or you know, investment products that are, you know, not that easy. So at the end, you need to have the right controls, you know, like human oversight. You need to have the, you know, correct governance, so that depending on the type of use case, you adjust your risk appetite and risk tolerance. And again, AI literacy is important so that, everyone using AI is aware of the limitations of AI and the proper use of AI with the right controls.
Thank you. I think we are at time. Let's thank our speakers. Thank you.
Have someone connected, right? Okay, great. Can you hear us? John, can you hear us? Great. So let us think a bit. You have been discussing, you have been listening to very interesting talks from different panels on different domains about pharma, about insurance, the recent one on the financial domain, on banking, and many different technologies, LLMs, agentic AI, Gen AI, etc. But there is a missing piece, which is not simply a missing piece. It's not simply a facilitator, it's an enabler, and that's the infrastructure. And we need to come to that. We need to think that to have any of these technologies being feasible today, to enjoy the benefits, there is something that is core, and that's the infrastructure part. Not only that, right? We have the exponential growth of users, we have the exponential growth of the different uses, which means that it's not just a requirement of the infrastructure, it's that they also have additional requirements. We have specific requirements in terms of response time, I guess, requirements in terms of latency. So many different things that push also the infrastructure to its limits. And we couldn't think of anyone that could be best to, to discuss on such topics, other than, I guess everyone comes to mind that NVIDIA is the thing to discuss here, and the facilitator of all this, and John Josephakis, who is the global VP of NVIDIA, having a long, successful record in previous companies such as Hewlett-Packard and Cray. So, without any further delay, I think we are all looking forward to listening to you, John. The floor is yours.
Aristopoli, thank you so much. Hopefully we can go over this. I haven't done a presentation on Keynote on Teams since many years, through the COVID years. So I might need to adjust and make sure that you guys can see me. I don't know if it's coming through okay. And I also didn't know if you want to, I sent my presentation to you. I don't know if you want to share it or if you want me to share it. If you're talking, I can't hear you. Hello?
John, do you want to share it so you can also browse through the presentation yourself? Do you want to share it so you can browse also on your presentation yourself? You can share your screen.
Is that what you want? So I just didn't know. Can you see my presentation?
Yeah, that's great. Thank you.
Super, yes.
Okay. Kalimera, good morning or good afternoon to you guys. Hopefully this is coming through okay. I wasn't, to tell you the truth, I'll be very open here. I wasn't sure in terms of what, you know, the audience and how much I can say and what areas you would like me to go to. But I put this presentation together. I've been with NVIDIA now, a little bit about me, just so you guys have a context. As you know, was said, I've been with NVIDIA a little over 6 years, and my previous life was at Cray Supercomputers. So based on that background, Jensen Huang and the team brought me on board and said, we want you to be our global leader for high-performance computing across all verticals and also the supercomputing world. That started, but soon the world has changed, as we all know, and it keeps changing dramatically. And I think the acceleration has been the acceleration of change is such that things change on a sometimes weekly basis. So I try to keep that in mind and give you a little bit of background of how NVIDIA became the leader, I think, and how by investing in the right technologies and in the right areas, NVIDIA is what NVIDIA is today and what I think it will be continue to be for the future. Basically, we have three things I want you to keep in mind that keep NVIDIA going. Supercomputing is one of the architectures that started with modeling and simulation. A lot of you probably have the background of high-performance computing around that. And then AI is something that we've known about. Machine learning, it's not a new thing, but it wasn't really adopted until recently. And of course, another pillar that, you know, in computing that we have been looking at, and in the last, I would say, 2 years, 18 months to 2 years, has gotten a little bit more heated, is the investments we see in quantum computing being the next potential game changer for what we do. Again, inference is the new factory floor where we see the reasoning models, the agents that are driving a lot of the work we're doing. And I know there is a lot of marketing that goes on around agents and models, but I don't want you guys to think of ChatGPT as the next thing, or Llama or Gemini or Claude or OpenClaw. But I want you to think of what that AI technology and those agents can do to every person in their life. And at NVIDIA, for example, by the way, I'm a user of all these tools, okay? We use these tools not because we want to find out what we should buy our wife or our kids or whatever, but I use it to make me more productive. And frankly, we use it all the time. And then, you know, we need to find out how, you know, adoption is gated by people and politics and infrastructure and all that. So we keep that in mind as we move forward. But so again, the supercomputing, the pillars, and I wanted to show you this slide to give you an idea of the history. This didn't happen overnight. And, you know, I'm old enough to remember 2010 as if it was yesterday, where, you know, the Japanese decided they wanted to do a system and put it in water and do the immersion thing. Then we understood in 2016, we had the Swiss actually with their machine Peace Dane, where they started using GPUs. Then the Department of Energy in the US, they deployed again these big IBM machines where they understood, the Department of Energy understood that there is a very important aspect that you don't need one GPU, but you need to connect multiple GPUs together. And the technology called NVLink, which we all know today, came into being. The Japanese came back with Tsubame 3 in 2016 at the same time, where they took the multi-GPU capability with NVLink and put it all together. And that machine came on. And then again, in 2019 was the year and I'm sure you've seen the pictures around with Jensen Huang delivering the first DGX Volta-based technology machine to OpenAI, that company that back then I don't think anybody in the room knew. I for sure didn't. And then again, we are starting to see this new technology now with Grace Hopper, what we call Grace Hopper, which, by the way, I also want to put here because that's going to be the machine called Daedalus, which will be coming to Greece, I believe, next month, in these next 30, 60 days. It's the technology that brought together the connecting the CPU, the GPU, and the network, and understanding how the memory bandwidth and memory capacity was so important to come together. So I wanted to show you the evolution of why NVIDIA is what it is, because it continues to evolve through time. Then the other thing that happened is people started to understand the use of GPUs and how the world has changed. And then recently, with the birth of all these AI factories and AI supercomputers, the adoption has increased even more dramatically. Even though those are not on lists that we see like the top 500, which the scientific community follows, the birth of accelerated computing and AI coming together has shown us that this graph is nothing short of a miracle on how fast it's grown, and it will continue to grow. Kind of a funny thing here is that even though NVIDIA is by far the biggest player in the space, we continue to grow our profile and our deployments as a percent of what people are using. So you would think that how much can NVIDIA grow? But as you also see with our financial results, we indeed continue to grow with new customers, new applications, but also with existing applications and customers. And this is driven, yes, by simulation. You see the graph, but AI is the big growth, and that continues to grow dramatically. And we're starting to see that even quantum, which was basically non-existent a decade ago, is growing, because as people are trying to simulate a lot of the quantum capabilities, that's something that is still growing a little bit at a time. But I think you need to, we all want to remain aware that the pillars are indeed moving, and that the growth is indeed there, even in simulation. And the reason for that is people that were using classical x86 technology to do modeling, simulation, CFD, CAE workloads are now adopting machine learning and other methodologies to advance the way they look at science. So I hope that makes sense. We have a lot of companies. Cadence is one of our partners who actually has one of their divisions in Greece with CAE, where 2 years ago, Cadence was exclusively a company dealing with x86 technology, and now has major adoption of not just AI, but accelerated computing. I wanted to put this slide because I wanted people to think of NVIDIA, and many people think NVIDIA is a chip company. Some people, and I'll tease, think of our stock price, and of course people think of Jensen Huang, who is a fantastic leader, not just for NVIDIA, but for the computing universe. But we also are really a computing company that accelerates all the different applications. And if you're a student at a university, if you're a professor at a university, if you're doing research development in a company, whatever that might be, from companies doing like TSMC doing lithography, or if you're building planes like companies like Airbus and Boeing and General Electric and Rolls-Royce, and I can keep going through every aspect of this. If you're doing life sciences or pharma companies, you can use things like Parabricks. If you're doing edge computing with Holoscan. So a lot of different software capabilities, and this is the major libraries. NVIDIA has even more. But I think the fundamental difference, and yesterday actually we had a visit from the president of the European Parliament, and we were discussing, and she was amazed that, of course, she knew that NVIDIA does chips. And by the end of the meeting we had, she's like, you're in every company I go visit, I just didn't know about it. And I think this slide brings awareness to how many things NVIDIA is doing. I'm guessing some of you have a cup of coffee in front of you. We even work with companies to optimize the way they're brewing coffee to get the best out of it. So a lot of different capabilities and a lot of different areas that NVIDIA touches. Again, this is more a little bit of how science is changing. So a lot of people in the past, they would load their code on their x86 machine and do things. But today we have a lot of places around the world that are working with AI for science, is what we call. And since I was invited by the University of Piraeus, again, this is one of the things that we see a lot of the academic institutions and what they're doing to advance science in many different areas. And here you'll see we have some companies, but we also have a lot of work happening at research centers, universities, University of Texas actually, where I happen to go, and the work around seismology, which might be relevant to you in Greece with all the earthquakes, and the studies they've done with taking signals from edge devices, processing them in now seconds versus days and months to understand how different wavelengths are bringing knowledge much faster. So these things were, again, not there. The pricing also to do some of this work has dramatically decreased because you're able to do a lot of work on, for example, one GPU versus a whole system of x86 CPUs. Weather modeling, extreme weather phenomenon is another area. I think we all, I don't know what the temperature is in Athens today. I should have checked that. But the weather is changing dramatically. The Mediterranean is seeing that. And again, understanding the weather patterns, the climate, and the extreme weather phenomenon is something we spend a lot of time on. And we, of course, we all understand that energy is one key aspect of the world. So a lot of effort going around energy, and it's no longer drilling a hole and getting all out of the ground. It has a lot more things that people are looking at. So hopefully that gives you an idea of things that are happening in different areas of the world. So again, so AI and physics, we had the pure physics and we understand that based on first principles. And NVIDIA is always has to have the grounding of first principles in everything we do. So we look at that, we work with our customers, but then we bring in the AI to augment the work we do in physics and first principles. It's not like we are going to replace the engineers, the scientists with AI, but we want to make them much more efficient. I don't know if any of you or some of you might have seen Jensen talk about how NVIDIA is using it and how NVIDIA is actually hiring people. But we are very focused on actually drinking our Kool-Aid. And like I mentioned in the beginning, I use a lot of AI to help me. It doesn't change my fundamental beliefs about modeling and simulation and principles of coming out of math, physics, chemistry, biology. But in all aspects, we find ways to augment those processes to make them faster. Material science is an example of a lot of this work that we've done, and it has applicability in many different things we work. And again, the libraries are there for people to download and put next to their standard codes that they've been using around, for example, CFD, CAE, and make them look better. WRF in weather and climate, or ICON, a lot of the European codes. We work very closely with ECMWF, the European Center for Medium Weather Forecasting, among others, the Swiss model, and so forth and so forth. So a lot of work and collaboration is happening without forgetting, I don't know how many of you still use Fortran, but I can tell you NVIDIA is very focused on continuing supporting Fortran, C++, and other codes like that. But in order to do that, as it was said, NVIDIA is also trying to think of what's next and what's next. As you can see, the innovation is changing dramatically. When I joined NVIDIA 6 years ago, we were on a 2-year cadence on our GPUs. Since then, you guys probably follow the news a little bit. We are on a 1-year cadence, and that's not just on GPUs, but we now have CPUs with our Grace and Vera line coming on board. But we are also looking at all aspects of the system, not just compute, but networking, the software, and everything comes together. And again, when we do this, we don't look just at the hardware and the GPUs, but we look at, again, emphasizing the whole system, the software. We continuously upgrade our CUDA baseline and looking at how do we take the best advantage of every aspect of the system. When the Daedalus system comes to Greece, and it's a 2,000 GPU machine, not huge, but not tiny, you will start to understand that the sum of 1 + 1 + 1 is not 3, but it's going to be 7 or 8. And that's what we see from our customers, but that by working closely and putting all the technologies together, you're going to get a lot more performance. This gives you an overview of what I just said in terms of putting things together from the compute to the system and all the aspects that come along and why we have them. And the other thing that we want to help people is to show them our roadmap, show them what we're thinking, but also don't have them wait. Waiting is really one of the worst things that you can do to science, because you stagnate, you don't innovate, and you just sit there and wait. Versus even if you have a little bit of an upgrade as you move, that becomes a very key to keep the innovation going. And I think we see that most research organizations, corporate as well as public organizations that are successful, are people that continuously invest and continue to look in their future. And I'm not saying, oh, buy a huge system every year, but continue to invest and take advantage of technology. And then, we came to the area of enterprise and agent era, where people are deploying a lot of the work they're doing, but also starting to take advantage of the new things. So we need to think of agents as our partners. And I want you to all think about that, because there is a lot of discussions out there about how do we use AI, what is AI, is it a threat, is it a partner? But I think by the way, to date, NVIDIA has not laid off one person. NVIDIA has made all our employees much more efficient by using AI, and we continue to hire people. I just hired 4 people on my small team, just to give you an example. So we use AI to even run faster. And I think we see that when we look at different areas. So we first try to compose what we're doing. NIMS is a NVIDIA term about finding an agent and making it enterprise quality and putting it as part of your workflow. You verify it, of course, by building the right guardrails. And this is something we help with all our customers. You don't want to have an agent become a rogue agent in your system, but you give them specific tasks. And I don't know how many in the crowd are using agents to help them with their work. I was recently in Greece, and I actually had a dinner with a couple of people, and they were saying, I use it all the time. And these people are CIOs of companies, and they're using them to help. So they're using Claude, they're using Gemini, they're using OpenClaw and NemoClaw from NVIDIA. So I think you just need to give it specific directions to help you with what you need. And then, of course, then you deploy it. And you just don't deploy it and let it go but you measure it. And I think you need to put all this together in order for you to be successful. And then continue to optimize on what performance you need, how many tokens you need, because either we like it or not, the world is moving very fast in what we call a token economy. And it's not about buying a machine and investing money in buying a machine. it's what you do with the machine and how do you tokenize the investment you do. A minister of a certain country, when I showed up, told me, "Oh, you want me to write you a check?" I said, "No, I don't really care about your check. I want you to invest in your country, into your future." And it's the same thing I mentioned to all the university deans and Britannies and people like that. Think of your students and think of the future of your nation and your university. If you don't invest and help them, you're not going to be able to grow the company. Actually, last week we hosted at NVIDIA 22 Greek startups, and I was very proud. And the people at NVIDIA told me, "Wow, this is a special day for you." And it was a special day for me because we had 22 startups from Greece showing up at NVIDIA to understand how the token economy is going to help them drive success. And a lot of them, I would say 95% of them, were kids in their 20s. So I was very happy, very proud that these people understood the value of the NVIDIA software and how we can work with them. And they ranged from legal aspects to robotics, to weather and climate, to pharmaceutical companies, so healthcare. So it was a lot of different areas of collaboration around token. And this is some of the open models that we've deployed, like I was saying. Nemotron is our agentic AI model that, again, you can take it and adjust it to what you want to do. Cosmos is our physical AI, robotics, and Groot, which becomes very, very important. It's one of the areas, actually, we discussed with the president of the EU yesterday, of the EU Congress. And then we have autonomous vehicle, BioNemo, and Earth-2, which is used for AI physics. Now, a lot of these models you can use across other disciplines, but again, it's open source, ready to be used by NVIDIA users. And again, agent as a service is another thing that I wanted to talk about, because as we move forward, we see that a lot of people are thinking of agents as a new platform for them. And like I mentioned before, think of an agent as your assistant. Don't think of it as a tool, but think of it as something that will bring you more efficiency. And we see that of how people are using agents to do their work and their tools and how they use memory and the compute and all that. Plus, it optimizes in many ways how you use your systems. Again, this is just touching a little bit to show you this is not, a lot of people tell me, "Oh, this is a US phenomenon," or "Why should we care?" But I think with this slide, I just wanted to share with you some of the work we're doing goes around the world, and it's all about adoption. And I think the countries that are going to adopt these capabilities are going to be able to sit at the table and have a seat at the table as we move forward in terms of their economies growing faster, able to accomplish more. And I say that with what, knowing a little bit more about Greece than I know about other countries, but I do know a lot. I usually have to change my passport every 2-3 years because it gets full, although it's getting better, and hopefully one of these days the machines in Greece will work for me. I have a US passport, so every time I have to get a stamp. But hopefully that will help. But I do travel around the world, and I have experience from, I was in Singapore and Japan last month. I was in Europe. I'm back in Europe next week. And now I'm visiting, we had the European Union. I'm visiting Lawrence Livermore National Lab. This is actually my next meeting in 45 minutes, where we're working with them on large language models, on material science, robotics, digital twins. So it's not just an American phenomenon. It's a phenomenon that we see around the world. I just finished a call with the French ecosystem, with the people at Gency in France. So it's and actually Greece has invested too in a partnership with the French Gency community. So I think this is something that's happening, and it's happening fast. And it makes me very happy that Greece is part of the game and hopefully will move as fast as possible in this area. Then, finally, I wanted to talk about factors affecting AI adoption. And as you know, because of all the background of the people in the room, data is very important. And how we adopt the different data and how we manage it and how we look at this tokenized economy is something very important. Understanding reasoning models and the different dynamics is very key. Of course, you have to understand and put the right guardrails on how you do the structure of the model so you don't have hallucinations. I think the world is learning very fast on how to do the reasoning and hallucinations. That's something that comes across. The reliability is improving every day, and when I say every day, I mean it, because I think it's something that so many people are working in. And really the biggest challenges we see are the compute and energy, because NVIDIA has this saying, the 5-layer cake. And in these 5 layers, the bottom one is the land and shell and the energy to drive the adoption of chips, of all the software, and then finally the applications. But if you don't have the land and shell, you pretty much don't have anything. And usually what we're finding actually is if you have land and shell, the two fundamental principles of your pyramid, then you're going to get the money, which is the capex, concentration, and conversation, which basically drives how our economies of the world are driven these days. So I think we see that if a country has land, shell, and energy, they're going to be able to build these AI data centers within reason, of course, and the money will come to drive their economies. And I think that's something we see and we discussed. I have discussed with government officials around the world, but also in Greece. And I think it's something that I feel that countries should be part of this, not just to help or sell GPUs, but because they will create the right economy and the right environment to create a flywheel within the countries for their startups, for their ecosystem to grow. And I think that was my last slide. So I wanted to finish about half an hour and I got this done. So if you have any questions for me, I have a few minutes, and hopefully that was helpful and not too fast.
Thank you very much, John. You touched upon several aspects. I don't know if there are any questions from the room. I guess there will be questions, but no. So I do have a comment. Can you hear us, first of all? I don't know if John can hear us.
Yeah, I can hear you.
Okay, so there were several interesting things you discussed. I found quite interesting the interplay between software and hardware, and I wanted to ask you to what extent is software driving changes on the hardware layer, or whether it's the other way around. I mean, hardware acting as the facilitator and changes on software come afterwards.
I think for us, the two are interconnected. When we look at all our hardware and the development process, we always look at how software is going to interplay. We actually ask our customers to provide us with the capabilities that they are looking to do. So, by the way, 70% of the people who work at NVIDIA are software engineers. And we try to understand what people are looking in order to be successful. And that's, we actually architect the system as one. That's what I kind of mentioned earlier. So software is critical to everything we do. And we look at, for example, if you take the big ISVs in energy, it's Schlumberger, SLB. So when we look at the energy sector and drilling, for oil, or for example, what we do, we work fully aligned with them. When we look at CFD, for example, for automotive, aerospace, everything else, we work with all the companies, ANSYS, Cadence, Siemens, Dassault, all the companies, we work next to them. When we go to work with the pharmaceutical and think about our future, we talk to companies like Lilly, we have a joint collaboration with them, for example, as one. Roche, you know, all these companies. I wish we did more with Pfizer because they also have a presence in Greece. So in every case, we work with General Motors, with Ford in the US, we work with Toyota, we work with Mazda, Hyundai, Kia, we work with Volkswagen, we work with BMW, understanding what they want to accomplish in the future, and that's how we build our systems.
And another question, I guess, you know, there are many students in the room, but they're maybe, you know, shy to ask you. So I make the question. What's your, you know, single piece of advice to them at this moment?
Send NVIDIA your resume. Send NVIDIA your resume. No, I'm just kidding. But I think whatever subject you're focused in, use AI to make you better. Use AI to make you better. Don't be shy. If you're studying physics, use AI. If you're studying material science, use AI. Make Claude your best friend. So are most of the people Greek in the room?
Yes. Yes.
Okay, so I'll say something in Greek. Όταν ήμουνα 17 χρονών έφυγα από την Ελλάδα και ήρθα εδώ για να σπουδάσω. And I followed my dream, okay? Κάντε και εσείς το ίδιο, but use AI and let that help you. Να αποφασίσετε με τη βοήθεια τι θέλετε να κάνετε. Don't think of, I have a code and that's what I'm going to work on. Open, you know, αν δείτε το desktop μου τώρα, έχω Claude, έχω Gemini, έχω όλα τα different things. Σκεφτείτε το μέλλον σας, but think outside the box. Αυτό θα είναι η επιτυχία σας.
Thank you very much. Thank you. Thank you for your time. Thank you very much.
Όχι, εγώ ευχαριστώ και good luck with the conference. I wish I was there, συγγνώμη, but ήμουνα στην Ελλάδα πριν 2 εβδομάδες και θα είμαι την άλλη εβδομάδα, Τετάρτη, θα περάσω για ορισμένες ώρες και μάλιστα θα συναντηθώ με το Υπουργείο αλλά και με την μεγαλύτερη εταιρεία στην Ελλάδα next week because they understand they have to change. So be an agent of change. Τα νιάτα είναι που they are going to drive the nation. It's not εμείς που είμαστε λίγο ηλικιωμένοι. Εσείς είσαστε τα νιάτα and that's why I decided to do this. Although my schedule is crazy, το έκανα γιατί είναι το πανεπιστήμιο και ξέρω ότι we need you guys to evolve and είσαστε το καμάρι μας. Όχι εγώ που είμαι μεγάλος άνθρωπος. Εσείς είσαστε το μέλλον μας και ελπίζω να έχετε επιτυχίες και αν χρειάζεστε κάτι, know that NVIDIA is always hiring, αλλά και αν χρειαστείτε κάτι, ελπίζω ο Δέδαλος να είναι μια μεγάλη επιτυχία για την Ελλάδα και είμαι πολύ χαρούμενος που το μηχάνημα θα έρθει αυτό τον μήνα στην Ελλάδα, τον Ιούνιο. So, ευχαριστώ πολύ και καλό απόγευμα. Γεια σας.
Actually is calling the day, so thank you very much for your participation today. I think that tomorrow we start at 9, right? So tomorrow morning at 9 o'clock. Thank you very much. Wish you a pleasant afternoon. Thank you.